during the talk.
No, 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 no.
Okay. Yeah, okay, cool. So, but I don't need to. No, I don't need to. Okay, then just let me know. How does this thing? Does it look alright?
Yeah.
To my belt. Ready?
I think the turn it.
Oh, okay. As we're editing, so
I'll just speak up.
oh, it's okay. Last year I was at EuroPython Bilbao. I was talking with Daniele and he was telling me his travels to Namibia and the Python community there and how they ran a conference together, and it was quite amazing what he was telling me. And so, also met Aisha in Prague, and we had like really awesome talks, and so I'm really happy to announce this keynote about Python in Africa by Daniele, Aisha and Daniele. So please welcome them, and yeah, thank you.
Good morning, everyone. Thanks for being here. Before we even start, we have some thank yous to say to you, of course, for being here, to the organizers for inviting us to speak, and to all the volunteers who have helped put on this wonderful week of Python and friendship that is a EuroPython. Genuinely honored to be here in front of you. It means a great deal to us. And just being here is going to be an important contribution to a movement, Python in Africa, that we're both deeply involved in. And we feel quite responsible here, speaking for a lot of people.
Yeah, no pressure.
So thank you again. We'll introduce ourselves.
So hi everyone, my name is Aisha Bello. I work as a virtual systems engineer in the global virtual engineering practice for Cisco Systems. Among other things, I helped do support for Django Girls. I started the Django Girls movement in Nigeria, and I've helped mentor and coach at other events. I also help organize Pi Ladies in Nigeria. And this picture actually is one that I've grown to love, because it was in 2015 and my first EuroPython conference and my first ever interaction with the Python community and even Python as a tool. So yes, do you think I look any different now than I was then 2 years ago?
I can't see from the thing, but you look just fine. I'm Daniele Procida. I work for DDO, a Swiss Django company that provides hosting and development services for Python and Django developers. I'm a great lover of Django and Python in its community and its conferences. I'm a core member of the Django development team. Yesterday, there was some remarks about people's level of Python power from Tracy Osborne. And I'd just like to point out that this is what I look like on television, by the way. I don't know if you can see, but it says that I'm in fact Python software. So let's not have any arguments about that. Now, what Aisha and I have been talking about a lot, and what we're interested in, is what Python mean for each other and what emerges from the encounter between them. And as always in an encounter, the most important kind of encounter is an encounter between people, and here it's the encounter between people that Python in Africa represents. And encounters really matter because they are what change people when they happen. And in our Python world, we can trace these encounters through the events that we stage. So we're going to start with our PyCons, our national scale international events where you get to meet new people. So we've got PyCon South Africa, which is well established. South Africa is quite different from most other African countries. And then after PyCon South Africa, since 2015, we've had PyCons in Namibia, and then since 2016 in Zimbabwe, and then coming later this year, the first PyCon Nigeria. And people are just like ideas. You have to spend time with them, you have to hang around with them and try and work with them in order to understand them. And that's why events where people meet are so valuable.
And another way you can measure activity is a Jungle Girls event, which is like, as you can see, we've had 62 workshops since Jungle Girls ever happened. The first one was in Uganda in 2015. And since then, we've had 62 workshops, and the highest of them being in Nigeria, which is 31 workshops. And I think what is more important for us to notice is that Jungle Girls events are happening in places that don't even have an established Python community in Africa, in places in Africa. And for example, in Africa, the World Bank had a report they published sometime in 2008 where it says 70% of SMEs are owned by women in Africa. So 70% of entrepreneurship in Africa are owned by 70% of women. Now, if you translate that to what that could mean for programming, it goes a long way to show the possibilities that Jungle Girls or even events like Pi Ladies can have an impact, not just Africa as a whole, but the African woman.
So, well, how did we get here? By the way, Aisha's very modest. I don't know if you saw that fully 50% of those Jungle Girls events have taken place in Nigeria. And the reason is right here, so she's too modest to say that. So how did it get started? Not the PyCon South Africa, which was already established, but since then. In 2014, I was working at Cardiff University School of Medicine, where I was the web team. And I had the notion of somehow helping to start a new PyCon somewhere in Africa, because there'd been these PyCons in South Africa since 2012, but nowhere else. And I was trying to find an African Python community large enough to host a PyCon. And I went to see one of my colleagues who'd done a lot of work in Africa for some advice. And this was Professor Judith Hall, the head of the anesthetics department. And she just looks like an ordinary professor, but in fact, she's actually a force of nature, isn't she?
Yes, she is.
Yeah. So she did have some advice. But much more interestingly, it turned out that she was starting a major long-term engagement project called the Phoenix Project between Cardiff University and the University of Namibia. There's Namibia, in case you don't know where it is. It's a large place. It's larger than the landmass of Germany and Italy put together, but there are only 2 million people, just over 2 million people living there. So the professor had many questions for me, like, what is Python? What is open source software? What's a PyCon? Why? And we had some lengthy conversations. But to cut a long story short, the idea of a Namibian Python software conference was adopted as an official part of the Phoenix project. And suddenly it wasn't just a notion anymore. We now had significant backing from 2 institutions. We had financial and logistical support. We had a lot of expertise. We had a venue, and we even had a guaranteed audience. And then we had dates, and we had sponsors to whom we are eternally grateful. And we had speakers and people who were committing themselves to travel from different continents to Namibia in February 2015. And this was to run a new PyCon in a place that I'd never been before, with people I'd never met except via email and Skype, and for an audience whom we discovered didn't even know Python yet, because even the computer science students studied Java and C and other things, and they simply didn't know Python at all. So my main thought was, this had better work, because in my darkest moments, at 3 o'clock in the morning, I was convinced that the whole thing was a preposterous lunacy and that this couldn't possibly work. And I imagined people speaking about me in the future, do you remember that idiot who tried to organize a PyCon in Namibia?
Did you also wish that the plane crashed? There was a volcano and you didn't have to go anywhere?
I was praying for ash clouds or international bans on Python events and anything that would mean I didn't have to go ahead with what I'd said I would do. But despite all of this, we found ourselves on our way to Namibia, and then walking into the venue for the first time, where we found all these people waiting for us with some excitement. And then suddenly we were in the middle of a real live Python conference, doing all the things you expect from a PyCon, doing all these things together. People meeting each other for the first time and discovering things for the first time. And that PyCon was a great success. But it wasn't actually that event that really mattered, but what happened afterwards. Because at that conference, the Namibians formed their own Python society, PyNam, the Python Programming Society of Namibia, and they got to work straight away. So the undergraduate students who'd been at the conference and had literally just learned Python, the next month they'd managed to organize themselves with local high schools, and they were doing programming demonstrations and lessons for high school students. So there's Jessica, she's the chair of PyNam, and this is from the second year of PyCon Namibia. And those are some of her high school students who came to the conference. So the Namibians took the idea and really ran with it. And earlier this year, we had PyCon Namibia 2017, the third edition of the conference. And just 2 years after that first event, PyCon is now taught at the university as a result of the PyCon. It's taught in high school, thanks to Jessica. Namibian businesses and developers have discovered Python. They say, wow, there's a software conference coming to Namibia. They don't get many of those. We better go and find out what that's about. So there's an active, growing community that's already organizing a PyCon now, PyCon Namibia, for next year. And one lesson from this is that you don't need a community to have a PyCon, because you can create your community out from the PyCon. And another thing that the second Namibian conference last year did was to lead to a PyCon in Zimbabwe, because two of the people who came in 2016 were Anna Makarudze and Humphrey Butau. They traveled well over 30 hours each way in a minibus. An absolutely horrendous journey. You know, after hearing about those travels, I've never once dreamt of complaining about my own long-distance journeys. And later that year, they started, they launched and held the first Zimbabwean PyCon. And if you think that organizing a PyCon is an achievement, organizing one successfully in a country like Zimbabwe, which has many internal problems, is facing international sanctions, is really a triumph of perseverance and strength and ingenuity. And if they can do that, they can do anything. So their first conference was a success, and the next one is taking place next month. And really importantly, it's sponsored by some companies that we already know and love. I mean, 3 of these sponsors are sponsors of this event. So I'm really grateful to these companies. I hope there's somebody from JetBrains or Nexmo here in the audience to see this, because this really matters, and we're so grateful for your support. To see not just that the Python communities are growing and developing in Africa, but that the rest of the global community is stepping forward to be part of them is literally a dream coming true. Zimbabwe, unlike Namibia, already had an established Python community. It's a much bigger country. Very briefly, there's Marlene Mangami. She's the first African board member of the Python Software Foundation.
She's a woman.
Yes. There's Ronald, who's and some of his fellow leaders of ZimboPy, which is an organization dedicated to getting girls into coding. And finally, last year in Namibia, there was another important person who also went back home full of plans, and she went back home to Nigeria, and here she is to tell them about them.
And that's the southern side of Africa. Now let's go to the western part of Africa. To start with, we're going to be having our first ever conference, PyCon Nigeria, September 15 and 16. And just take this as a personal invitation to come over to Nigeria, or come over to your first African PyCon conference. And which I want to take a moment to appreciate the team I'm working with. They've been so dedicated, and I have more on the next slide. It's our first conference, so trust me, we need all hands on deck. That's why we have so many organizers at this point. And thankfully, I would also like to say thank you to our sponsors so far that are sponsoring us, which like the PSF, GitHub, and Endela, which is like a local software company in Nigeria. Now, moving on to Python Nigeria. Python Nigeria organically grew from a Django Girls event. Now we have over 700 Slack members because we have like a Slack Python community. And we have over 1,000 PyLady subscribers. I have a good explanation for that, why that is, and we have just in a second. And over 500 PyData enthusiasts. So one of the things that we have in Nigeria, in Lagos, is that knowledge is sought after. People want to learn a lot, and the thing is, PyLadies is an opportunity, or is the only event that has consistent Python tutoring. And the thing is, not just girls actually come. Sometimes we even get more guys coming than girls to a PyLadies event. And at the point, we were like, you know what, guys, if you want to come, make sure you come with a girl, or don't come at all. You can't come and underrepresent us in our own event. No, it just doesn't work. So yeah, it was a bit of struggle there. And just to talk about numbers and how much of an impact this has been, we've had over 919 girls attend Django Girls events in 28 cities and with 31 workshops, and there's still more coming. And what's also important to note is that girls from Nigeria went on to Ghana and organized one workshop in Accra, and that enabled the Ghanaian women go on and are currently, just from 2 months back, going on to organize their own workshops in places like Kumasi, Ho, Koforidua, which is very, very, which is how the movement, or the Python movement, is spreading to other parts of West Africa, especially where there is no Python community or no Python presence.
Django Girls is sometimes not regarded very fairly. So some people think that Django Girls is all about cupcakes and heart-shaped balloons and a kind of girly party. So
it means a lot to us. In our part of the world, it's not news that Nigeria 2 years ago had made world news, where a sect called Boko Haram kidnapped over 200 girls in the middle of the night from their dormitory, and have held most of them for over 2 years now. And there was this huge campaign, and we even had Michelle Obama say, "Bring back our girls, bring them now, we want them alive." What I wanted to mention here is how Django Girls have gone on to help these girls that are internally displaced from the north, and trying to absorb them into the community based in Lagos. And a team called Abo Coders, which they're very passionate about, tech education in the north. And she's like, you know what, Aisha, we need one specifically for internally displaced girls. And this was quite different, because even the organizer, Simi, she had to organize a workshop for the coaches, because they had to be that conversation with them to say, you know what, these girls are not like your regular, maybe girls that you already coach. These are very special, and there is a way you need to approach how you teach them, or how, they ask questions and how you should answer. And sometimes we even had translators actually try to talk to them in Hausa language, which is what most of the language that they use for the most part.
So Django Girls is literally going into places where other people wouldn't even have the first idea how to begin working there. So I think that's really important to recognise the significance of this. And who are the people in this photo?
So Hamdullah is actually a treasurer from the Python Nigeria community. And the girl, she was one of the girls from Borno State, where Django Girls have been, where Boko Haram has been like a terror and a thorn in so many people's flesh. So moving on to how much more we've done the Python Nigeria community, we've actually partnered with also other organizations, and this time we went to Ajegunle. Ajegunle is one of the major slums in Lagos, and we went to a public school and picked 60 girls over a period of 12 weeks, and we we taught them how to code. Now this is quite unusual because many of these girls haven't ever had to they haven't seen a computer before. They probably learn about it in class, but as an abstract concept or as something, as a computer that you put in the shelf and is admired from a distance, and most people are scared to go touch it. And so with the help of Python Software Foundation, we're able to give these girls Raspberry Pis at the end of the program, not just the Pis, the screens, keyboard, mouse, because most of them are coming from homes that they probably could not afford computers. And what is important here, I would like to note, is that that in the picture is Tosin, and Tosin is teaching them, was at the beginning where we had to actually teach them how to type. We had to teach them what the computer is before you even begin to say, oh, let's go to the command line. We had to go from like the very basics and teach them this, which we had support also from a youth fellowship initiative and the founders of TechMe. One of the girls, called Jane, had this to say. So with the Smart Girls project, we made cover page of like a major newspaper in Nigeria, and she had this to say. She said, I hated computers because I kept failing the subject in school. I mean, who would blame her, right? I couldn't even put it on and off. I was scared each time I saw a computer, always thinking if I touched it, it will spoil, meaning if I touch it, it will just break, right? So it felt like this abstract thing. Now, all my fears are gone. I can now code. I'm also very bold now in the class when it comes to answering questions about computer. This actually is resounding because even giving the confidence in these little girls, and saying that they can do it, and it's not so much of a big deal, has gone on to actually change their perspective from a concept that they're very scared of to a concept that, you know what, I think I want to keep learning and I want to be a developer. So yes, this is how it went.
So we've talked a little bit about what's been happening, and now we want to talk a little bit, have a bit of a discussion about some questions that will help clarify the implications of all this. And I think the most challenging two words up there are in Africa. So we've talked about this quite a lot, actually. What is one of the biggest problems about talking about Africa?
Africa is not a big country. It's a huge continent. And it's not just huge, we have very different, no, go on and clap.
Yeah. Now they started clapping, they went stop.
It's made up of very different people and very different communities. And you'll find out that even in a country, for example, like Nigeria, we're in ourselves very different and probably have more in common with an Italian than we would have with a Ghanaian or Namibian. So we're very different. So there is no summing up Africa in one content. Africa is huge, and it's different experiences for different cultures and for different places.
Absolutely. So just to give you an idea, it's something like 1/5 of the world's landmass. So you could cram most of the other continents on top of Africa. Home to 1.2 billion people, some 50 plus countries. And depending on how you count them, between up to 3,000 different languages. So this is vast ethnic and cultural diversity. So, if you're an Italian and you're going to Belgium or somewhere saying, wow, it's so different here, you've seen nothing. And Africa is not just different.
We're very different from Africa. Africa is different from Africa, yeah.
Yes.
The difference is great as much as between a Nigerian and a Namibian as opposed to maybe a Nigerian and a British. It's actually very hard to travel within Africa. I'm a Nigerian and I need to get a visa to go to South Africa, to Kenya, to anywhere else, which is a luxury that I see that the European Union have, because once you're from Europe, you can go and you have freedom of movement, but we don't have that. And actually, Python Namibia was actually the first African country outside of Nigeria that I'd ever been. So we don't even know ourselves for the most part because the ease of movement is not as easy as it seems. Like, oh, it's just Africa, but no, we have to get a visa like everyone else that's coming from anywhere else. Sometimes it's even easy if you're from Europe to come to a country like South Africa than it is for like a Nigerian to go to a country like South Africa.
Absolutely, or Namibia, where most Europeans don't need visas.
Yes.
But Nigerians have to jump through hoops.
Exactly.
Yeah. Here's a question that we've encountered and also spoken about. What does Africa really need? Does Africa need access to software and high technology? Or does it need things like universal basic education, vaccinations, clean drinking water, and basic healthcare? In other words, aren't PyCons or are PyCons a kind of frivolous luxury in the African context?
Africa needs technology too. So we use technology, and this is where I see a role in open source software, such like Python. We use it to solve our own problems. Now we have people developing apps that can help with waste management, that can help people access better healthcare. Africa, it's not a luxury to have PyCon. It's a necessity that we need, and that's our reality. We need technology too. We need software. We have businesses. We have telcos. And no, it's not a luxury.
So it's Africa is going to need software. It's not an alternative reality where they don't use software. And since it's going to need software, it faces the same choice that everybody faces between being a producer or a consumer of the things that you need. And the choices for African economies are pretty simple. Either it can buy the software it must have, or it can find a way to build it, maintain it, adapt it, and own it itself. And if it can't do that, it will have to buy it. And that will mean valuable money leaving African economies. And this is where open source software comes in, because open source software, don't think that open source software is something magical, but it's an opportunity. It represents a possibility to make that possible, to make it an economic viability. And PyCons, as we saw from the Namibian case, are really important as a way of helping open source software get traction and users in Africa. There's another thing I want about technology. So if you think that technology is MacBooks and iPhones and wearable technology and things like that, then maybe Africa doesn't need those things. But if you stop thinking of technology as stuff that you buy and instead think of it as skills, then the question looks different. And saying, does Africa need technology, becomes the question, does Africa need skills? Does Africa need practical knowledge? And then it has a very different complexion, and it's much harder to think that skills are
a luxury.
Yes. We like denying that Africa doesn't deserve to have knowledge. I don't know if you know these gentlemen. They invented my MacBook. There's Steve Wozniak and Steve Jobs. Now, paradoxically, and Aisha will tell you more about this in a moment, free things can be unaffordable because they're free. In the African context, the hobbyism that strongly characterizes the open source software movement really is a luxury, because we're used in the West to building projects, skills, contacts, even industries as hobbyists, as amateurs, spare time enthusiasts. But all that is only possible when there already exists a well-established industry and networks, when there's an established faith in the industry, when there's plenty of spare money and spare time and easy access to resources and information. So hobbyism is kind of parasitic on established business success. And you've got more to say about this subject, I think.
I'm sorry, did you say hobbies?
Yes,
We
hobbies.
don't have time for that. The thing is, we need to make sure that whatever we're doing can at least generate revenue, because money is not a dirty word if you don't have lots of it. If you have to if you're living in a place or in a country where there's no 24-hour access to electricity, and you have to buy generator and buy fuel to run, and you have to ration, okay, how much charge do I have on my laptop versus when do I turn on the generator and get charged, and how much longer can I work with, and you have to deal with noise pollution, air pollution, noise, everything. And we don't have time for hobbies. We need to make sure that whatever we're doing is profitable, is productive, right?
I think you should say, though, where we're talking about that you can't rely on 24-hour electricity. Are you talking about the remote backwoods of...
No, so this is Nigeria, which is a different reality for Namibia.
In which cities?
Almost every city.
In big cities. So even in big cities, you can't rely on...
Yeah. So you can't rely on that. And we don't have time for that. So there is the aspect of we need to make sure that whatever we're doing can generate money. So we need to make sure that we can afford the time. Time is a luxury for most people because you have to make sure the power is banked. Some people don't even have computers at home, so they need to borrow. So there is like so much we're working against, or so much working against us, that even sometimes the basic necessities are like a luxury, where you don't even have internet for the most part. So it's work. It's not fun. And that's why Python's for us is serious business.
Yeah. So I don't know how many people here have also been community event organizers. Has anyone else organized a PyCon here, or an event, or even a meetup or something? Yeah, I see a few hands. Well, you'll know that you'll have faced all kinds of challenges and spanners in the work, and you don't have to go to Africa to find them. So this is from my DjangoCon Europe in 2015, when a boy band disrupted our conference by suddenly selling every hotel bed in the city after our conference had already started selling tickets. Or in the PyCon UK a couple of years ago. So anything can come up unexpectedly. But still, let's look at it this way. Python in Europe is, it's funny. There's Monty Python, and Python software is characterized by this light-hearted tone that Guido van Rossum very wisely established right at the beginning. And we enjoy it in all kinds of ways, so it's fun. You have funny snakes and so on. What do you have to say about funny snakes, Aisha?
Snakes in Africa is not funny. I'm really serious. Take, for example, in Nigeria, for a period of 6 months, we were trying to register as a not-for-profit with the government, and it took us a lot of going back and forth, and we had to change our names so many times because the government, or the officials were like, Python? Are you a cult? We don't approve such. And no, this is actually after giving them a 5-page document explaining open source and what Python does and how Python is a software. We eventually convinced them after 6 months of going back and forth and changing our names, and finally say, okay, and they told us, they gave us a name and said, why don't you say Python Software Community, so that it's very explicit and no one thinks that, because for us, Python represents negative. It's a threat. We see it as a threat. It's harmful. I mean, people die from that thing, So it's not funny for us. Another example in Zimbabwe was when a parent actually pulled out a child from a Jungle Girls event because she saw me with my EuroPython shirt and a huge snake was it, and she's like, there's no way I'm going to let my daughter be a part of that. There is no way. And, it took Hannah actually having to go to the woman and explain and tell her, explain to her what Python is as a software, but not Python as a snake or as a demonic idea that many people are used to. Same thing happened in Osogbo, in the western part of Nigeria, where a company actually at the last minute pulled out from hosting the Django Girls event because they said, Django? No way, that's like Django Unchained. If anyone has ever seen Django Unchained. It's against our religious belief and we will not support that. And a day before the event, they had to run around looking for another venue. And it just, sometimes it's preposterous, it doesn't make any sense. But this is our reality.
we just have to be careful with our snakes because they might not be as attractive as they are to us as they are to other people.
Do you think if Guido had an African friend, he would still have called it Python?
Yeah, if that's a good point. So if Guido had been developing Python in the beginning with an African friend, perhaps the name Python would have made them stop and think for a minute. So this is, you can't have too many useful perspectives when you're creating something. But this isn't really about snakes. It's about meaning, because in a global community like ours, symbols and images and names are going to have unexpected meanings, and we can't rely on a narrow cultural perspective to find things that will work well. Aisha, can you explain to our audience what African time is? I think this might be important for anybody who's planning to go to an African PyCon.
Right. So I will cut the long story short. But an advice to everyone here, if you're ever going to organize an event where you expect Africans to attend, and the actual time is 7 p.m., in the invite you send out, tell them it's actually 4 p.m. Give them 3 hours buffer, because if you say 7 p.m., no one is going to arrive at your event until 9, and you don't want that, right?
Yeah, we're organizing the events in Namibia. Namibians are extremely relaxed. They're much too cool to hurry. So everything does happen, but it happens in Namibian time. Meanwhile, the European co-organizers are sitting at home going, yeah, because nothing seems to be happening. But in fact, it all just happens at the last moment. The other important thing is that the personal touch, I think, this is a consistent thing in Africa, isn't it? That,
yes. Did you experience this when you
yes.
were in
You can bombard people with email messages for months and nothing will happen. And then you walk into their office and talk to them for 45 minutes, and the first 30 minutes of the conversation will be about their children, and in the final 15 minutes, absolutely everything will be organized in a way that you could never do in Europe. So there are different ways of doing things, and it's less stressful if you know that it's going to happen like that.
Yeah, heads up, guys, heads up.
There's another thing, expectations work in other ways too. So there's a long history of African technological brilliance and mastery that when discovered by the West is not even recognized because of disbelief that it could have come from Africa. So I don't know if you've heard of the Benin bronzes. They came actually from Nigeria, not from Benin, from the ancient Benin kingdom.
Oh, I come from that state.
You come from
Edo State,
Edo
yeah.
State, yeah. So the Benin bronzes were these thousands of works created in the 14th and 19th centuries. They're not actually bronzes, most of them are brass or other materials. Most of them are now in Western museums and collections because they were all looted by the British in 1897. But when they arrived in Europe, art experts were astounded, and they couldn't believe that this stuff had been made by people so, quotes, primitive and savage, not just because of the art, but because of the understanding of metallurgy that went into producing things like this. So they kept coming up with different theories about how the Africans managed to make these things. They must have learnt it from the Portuguese traders, for example. And they just couldn't believe that this was African technology. So that's just one example, but I think there's a real danger that if some new technological advance comes out of Africa, it simply might not be recognized because it won't fit Western or European expectations. But it's not just Europeans who might have to reassess their ideas of African technology, is it?
No. Will Africans buy African technology? So we sometimes have the mindset that, which I would say resulted from back in the day, maybe in colonialism, where we feel that things foreign or things abroad are better than what we do or what we build within Africa. So we've actually started a lot of movements around buy Nigeria to grow Nigeria, buy Naira to grow Naira, buy Namibia to grow Namibia, buy Africa to grow Africa. And this has also translated into technology, where we're trying to encourage companies within Nigeria to buy our own locally made software, as opposed to believing in the softwares that come from the foreign anywhere else, Asia, Europe, or even America. And this is just an example of how Nigerians love Italian shoes, right? There's this class that goes with, oh, my shoes are Italian. You don't want to say, I have a made in Aba shoes, right? Because Aba is a city, is an industrialized city in Nigeria. And so I've actually started this movement of buy made in Aba, because we're as good, as much quality as you would get anywhere else in the world.
We've been talking about Python in Africa, but what about Africans in Python? So if there's going to be a new generation of African Python programmers or Python community members, what new ideas or applications or insights are we going to see coming out from them? What could we imagine?
We just don't know, right? We don't know yet, but we better be prepared for it when it comes, right? Because we already as a community understand the importance of diversity. Diversity not just in gender, diversity in different domain knowledge. So now, imagine bringing the community of African Pythonistas integrated with the rest of the world. Just imagine what that could mean. But I have no idea. We don't know yet. Yeah.
So, but don't be like 19th century art critics and simply miss it when it's staring you in the face. So what's next for Python in Africa? Well, I honestly think Python is special, and there's a good reason why that first conference was a Python conference and not just an open source software conference. It was because of the community of friends, of companies that we knew we could rely on to make it happen. And we've seen how the community internationally has helped start not just a PyCon in Namibia, but also a Python community for Namibia. So Python's the way in. It's not actually about Python. You know, it's not for us to say what software Africans should be learning. Africa is going to need to make its own choices. But Python gives us a great way into introducing these technologies and skills into Africa. Python, because of its community, probably also because of the strength of the language itself, can lead the way. So the future looks pretty good. But the last part of our talk, just a couple of minutes left, is we want to address you as our audience who've been so kind to listen to us now. And we want to frame a question in your mind. Does Python in Africa need your help, or does it need your participation and engagement in Africa?
Africa does not need to be saved or taught, right? We can do a lot of these things ourselves, but we want to be a part of your community. We want to be a part of our community, not just about charity. We want you to come. We want you to teach maybe, and we also want you to learn from us, because there's so much knowledge that you can gain just by talking to someone completely different with a completely different experience than you're already used to, or to the people around you. So yes, we want your participation. We want you to join us.
We want to join us.
Come to an African PyCon.
It's really an invitation. There they are. You know where to come over the next 12 months. We want you to make new friends in Africa.
And keep them.
Yeah, because when you have an experience like that, it's something that will stay with you for your entire life and will be something really meaningful. We don't want you to be a tourist.
Be a Pythonista in Africa.
If you come and have the experience of finding out from an African schoolboy what his plans are for the future in computing for his country, that's an experience you'll never have as a tourist. So what we're offering you is a chance to literally to change the world.
And to take part in the future.
Because the future's right here. There it is. And you'll be amazed what a difference you can make to it. And there's the future. And there's the future. And you'll find that you, too, are transformed by the encounter.
Yeah.
So, thank
Thank
you
you
very much. Thank you.
Thank you, Aisha. Hello? Yeah. Thank you very much for this very inspiring keynote. As a EuroPython organizer, I have an immediate question. How can we learn to figure out to set up a conference like this in 5 minutes? It was...
Sorry, I didn't hear the...
Oh, actually, you said everything can happen there on short notice, like in the last 5 minutes.
Yes.
And I was just like asking, like probably a rhetorical question. Can we do a workshop for this for EuroPython?
I mean, I can actually give... sorry, I think my microphone is making a lot of noise. We can give an example of that in the second PyCon Namibia. We got... I'm not sure who's making that noise. In the second PyCon Namibia, we got a call early in the morning to say that the conference wasn't going to start that day because there were student protests at the university and the venue was shut down. Now, fortunately, we had a day in hand because we'd planned a social day at the end of the conference. So we went straight to a hotel and we said, we've got a problem. We've got 120 people coming for a Python conference. We need audiovisual supplies, services in 2 different halls, and we need catering for 120 people, and we need it tomorrow. And they said, yeah, we can do that. And if you tried that anywhere in Europe that I've been saying, wow, it's impossible. So things do happen, and can happen in different ways. Yeah. We're happy to take some questions from the audience, aren't we? Yes,
sure.
Keep them
Questions.
short
Raise
as
your
possible
hand.
so as many people can have questions as possible.
Hello, thanks for the amazing talk. It was super inspiring. During the last few days of the conference, I met people from all over the world. And what would be your advice for them if they want to start a local Python community in their own city or country?
Hi. Okay. Well, I would say the best way is to probably reach out to... It's always easier when you have someone on ground that can help out. So the best way would be to maybe reach out to a community like ours or any other community in Africa and be like, okay, we want to start another community and let this collaboration exist. As opposed to trying to organize from outside without having anyone on the inside that can help push them, because you still need, even with a community, you still need to be able to have that personal touch, that one-on-one contact with someone. And honestly, emails are great, but there's nothing still beats personal communication and interaction. So yeah.
Or you can just get lucky and find that your colleague is planning this multi-year project. So it's just, things to happen just by chance. You have to talk to as many people as possible, and you will eventually talk to the right person, I think.
Yeah.
Thing.
You'll turn off our headphones? Okay, we'll use this microphone instead, shall we? Yes, okay, we'll do that.
If we're on the same frequency,
Yeah,
I've just
okay.
been advised. I'm very sorry
Yeah,
for this.
wonderful.
Questions, here's the next question. And if you have any more questions, please come down here. If you sit there, please take this route, and everybody from here just come down for questions, because I was till the social event until 3 o'clock.
Okay, so I actually met a person from South Africa at last year's EuroPython, and he invited me to PyCon Namibia, but I kind of chickened out because, like, Johannesburg isn't the safest place in the world, to be exact. But like, if I come to Python Namibia, for example, like, can you tell me that it's going to be okay, and I don't have to worry about anything, for example?
Okay, so this is, Africa is unknown to many people. You met Ivan, our friend from South Africa. Yes, so he's coming to Nigeria, of course. Yeah. So he's a wonderful person. Namibia is a democracy with a functioning free press, a robust free press, has elections and governments that get voted out by the people, and people who lose their jobs in the correct way. It's a really, really safe place to be. It's much safer than most of South Africa in terms of personal safety. And even places that are less stable than Namibia, they're not wild places.
Exactly. It's not like you'll be walking on the road and someone's just going to grab you, for the most part. And we're aware of this problem, and most communities, like for PyCon Nigeria, we're actually putting some extra security measures to make sure, I mean, it's in Lagos, we don't usually have as much occurrences like in the northern part where there's Boko Haram and there's terrorism. So yeah, it's not always kumbaya, but...
Yeah. Our friend Luke, who's been to every PyCon Namibia, came this year with his 7-year-old, or his 6-year-old son. So, you know, it's perfectly safe. We should mention, though, that most African societies are quite conservative, socially conservative, aren't they?
Yeah.
So, unfortunately, for gay or transgender people, Africa might not always be, sadly, the most welcoming place. And it's not for Europeans to start lecturing Africans on what standards they should have. But I hope that this encounter that we've been talking about might change some of those attitudes just because people are meeting each other and being friends. So, I mean, there are things to be aware of. In many places in Africa, homosexual activity is not legal, sadly.
Yeah.
So, one more question from the audience. I might want to skip in one of my questions as well. So, are PyCons in Africa, then do they have like a similar code of conduct as we do in Europe, or is it maybe an issue to set something like this?
So yes, we do have a code of conduct, and we have just like a EuroPython having like dedicated people specific for that. You know, don't do anything, just code of conduct, because this is very important and very crucial, because everyone needs to feel welcome. Yes, we do have in our conferences.
And taken extremely seriously as well, yes. And we're not shy of putting in the code of conduct that, for example, homophobic behavior or language is not tolerated.
Yes.
So we can still share the values of our community where we go. You just have to do it in an appropriate way. Yeah.
Hi, thank you. It's quite inspiring. You've shown that it's growing really fast. My question to you is, what does it mean in numbers? When can we say that, let's say, 1% of new graduates know Python?
I'm not sure I get.
When can you say what?
That 1% of new university graduates had some experience with Python.
Okay, so for example, in Nigeria, Python is not being taught or as a standard in universities. What we have now, lecturers actually part of the Python Nigeria community, single-handedly championing teaching Python in universities. So for example, people still learn COBOL, Perl, Basic, Pascal. Yeah, those kind of languages that make you cringe. And you know, some more modern universities do C, C++, and Java. But we're hoping that with communities like this, we can, you know, make it a standard, because honestly, Python is one of the very friendly, beginner-friendly languages to learn.
Yeah, people have said this multiple times. People have said that multiple times to us in Namibia, for example.
Hi, thank you. Speaking with friends that works in cooperation in the African countries, they told me that after they set up institution for teaching medicine, engineering and so on, one of the problems they have is that they come from many European and American countries to teach, and when the students have learned, they just leave as possible their country. So in time where they go, after each 2 or 3 years, they meet always different people because, well, that's it.
Yeah. I think one of the things that we've discovered, Aisha mentioned, she talked about the kind of seriousness in which this is all taken, like the Django Girls events in Nigeria, where they're tackling really serious things. And I showed you some of the pictures from the school children giving lightning talks in Namibia towards the end. And every time one of these young people stands up in front of a microphone, they're talking about how can we what they want to know is, well, how can we bring what we've just learned to other people, maybe in rural areas of their country? So they are thinking about their own country and about people in their society who actually don't have the same opportunities as them. And we've seen them, for example, the university students going into the schools straight away to share their stuff with the kids. So I think the actual Python community keeps people together. If people have got skills, they'll find those skills are at work in their community, keeping people in the country, generating work in the country, and revenue and money and so on in the country. And that's the hope.
Yeah, I mean, a personal example is I learned about Python when I had the opportunity or the privilege to be here in 2015 at EuroPython. And then I went back home and organized just one event, and that had like a ripple effect, where now we have like 31. So it's like I've learned so much about the community, which is so amazing, so great. I want this back home, and I took it back home. So I would say it differs for many people. People have what motivates them. Because when I learned about Django, I was like, I need to go and show women in Nigeria that we're not all about fashion and catering, that we can code and we can be good and great engineers too. So it differs.
Because people are literally... there's nothing wrong with video games and the fun part of programming and computing that many people enjoy. But you'll see that when people get hold of this technology in Africa, they want to turn it like Ronald's, so that a Zimbabwean factory manufacturing soap can work more efficiently, so that market traders can find a better, make sure that they sell all their food. They're concerned with real local problems, and that's what's on their minds. And so I think that is what keeps people there.
Okay, we're already running way over time, so one last short question, short answer, but I guess you're around today all day, and I think you're very happy to ask any questions which come to our mind, I guess.
Rwanda is ready for a PyCon. I don't know how to do that, but it really needs to be done.
Yeah, he said Rwanda is ready for PyCon, and it has to be done, and he wants to, be the champion of that.
What, sorry?
Rwanda.
Oh, Rwanda.
Yeah.
Yes. There are Django companies in Kigali, for example. Yeah. So, thank you so much for listening to us. It's meant an awful lot to us to be here. It's a huge honor, and means a great deal to us. There's some information there that you should follow up, or you can follow up with Aisha and me. We'd love to talk to you. I have some PyCon Namibia stickers if your laptop has got a blank space on it. Thank you, and we'll see you at a PyCon in Africa. Thank you.
We have William here to talk about lessons learned building a medical chatbot in Python. Give him a big hand.
Brilliant. So my name is Wilhelm. I work at Babylon Health, and it's a real privilege to be here, so thank you very much for having me. So to provide affordable and accessible healthcare to everyone on earth, that is the mission of the company I work for. And it's been a real privilege over the last 2 years to spend the majority of my waking life trying to solve this problem. And when I joined 2 years ago, we were a really small company. There were like 40 of us, and we really kind of honed in on the accessibility part of this statement. Because at the time, if you were sick, you would somehow have to physically transport your sick body to some health epicenter where there's a high concentration of healthcare professionals that can help you with your illness. And in an age where everything from information to cat videos was highly, highly accessible, it just seemed well within our reach that we could make healthcare a significant degree more accessible by leveraging the internet, smartphones, and modern technology. So we went for it, and in July 2015, Babylon launched their answer to this accessibility question with their telemedicine application that essentially allowed people to have a GP consultation with the doctor over the phone and the whole kind of healthcare service that goes around that. So after the team kind of recovered from literally doing blistering hot fixes while our CEO is stepping up onto the stage at the Royal Albert Hall, everyone relaxed, patted themselves on the back for making healthcare a significant degree more accessible. But the affordability part is the tricky part, because 2/3 of the costs of healthcare go to the salaries of doctors, nurses, healthcare professionals, etc. So we need to figure out, how do we solve this problem? If we want to make healthcare more affordable, we have to somehow reduce the cost of healthcare professionals. So one way we can do this is by simply just increasing the number of doctors. And that seems like a kind of reasonable approach. But some people estimate that we are 5 million doctors short from providing affordable and appropriate healthcare to everyone on the earth. And not just that, doctors are expensive to train. They take a long time to train. It's a very difficult training process. So this approach just isn't going to work for us in the short term. So affordability is really tricky. We had kind of made good progress on accessibility, and we just kind of put our heads down, fixed bugs, added features, and just kind of went on our merry way. But then one day, Ali, our CEO, watched the movie.
Thank you. Please wait as your operating system is initiated. Hello, I'm here. Hi. Hi, I'm Samantha.
And ever since that fateful day, movie, this question came up again and again and again in meeting after meeting after meeting, as this kind of idea was starting to take shape in his mind. And they say it takes 20 times of repetition before something starts to sink in. And after his kind of relentless repetition, this idea started to kind of take shape in the imaginations of the engineers as well. And the idea is basically quite simple, right? So we know we have lots and lots of doctors short in the world. And doctors are just inherently difficult to scale. But we know something that's easy to scale. We know that machines and software and computers are really trivial to scale. So if we could just figure out a way to kind of put some of the doctor's brain inside of a computer, just one computer, then we can just scale it really easily and then iterate on that. So this was kind of like, it was a really kind of daunting, idea, and how are we going to do this? Medicine is so complex. So before we did anything, we built a demo. We wanted to see kind of how people would take to this idea, how people would feel like sharing, their healthcare concerns with an app. So we built a demo.
Headaches are really common and they're normally easy to treat. So don't worry, you're going to get started in 5 minutes. Hi, first things first, your heart rate is a bit higher than usual in the last week.
So I was in the iOS team at the time when we built this demo, and while I was building this demo, I kept saying to Ali, Ali, I don't know how we're going to build this. I don't know, the stuff that we're kind of suggesting we can do in this demo, I've got no idea how we are going to do this. But the reception of this demo was so amazing. People loved it. People were so encouraged that there are people thinking in this direction and the implications it has for healthcare around the world, that with just that gave us kind of enough motivation and inspiration to, not knowing how we were going to do it, just kind of step in and see what we could do. So I'm going to take you through a bunch of the things we did and challenges we had. At the end, I'm going to talk just a bit about the role that Python played in this whole journey. And at the end of each section, I'm going to just share with you some of the lessons we learned. Because some things we did, we were like, oh wow, that works surprisingly well. And lots of things we did, we were like, wow, that was a really bad idea. So let's start with medical triage. For those who don't know what medical triage is essentially you arrive somewhere with a set of symptoms and someone figures out what you should do. So should you go to the hospital, go to the pharmacy, stay at home, monitor for a couple of hours, it's like the step below diagnosis. So just kind of suggesting what you should do. So we knew we had to do this. We knew we had to be able to take medical queries and suggest to people what they should do next. And building this medical triage system was a real roller coaster ride, because we started off just being like, it's just a basic decision tree, We just kind of build out this tree, we get some doctors to help us, and then we just kind of walk down the tree until there's no more questions to ask, and we can, give them the outcome at the end of that branch. But then it's kind of like we dipped the roller coaster, and it was like, oh yeah, but this question is way more important than this question, and when these two questions are answered in combination, they kind of nullify each other, and our minds were just blown with the kind of complexity of this kind of medical sphere. And then we'd kind of come up again, because we had some really good data scientists who helped us kind of blow by some of these problems, and we built it. The first, because essentially, without kind of going into the details of how we weight questions and that kind of stuff, it is just a decision tree that you kind of walk down with some kind of intermediary logic in between. And we built the initial version in PHP with MySQL, and it just wasn't working for us. It was clunky, it was difficult to change. Some of the changes were quite risky, so we scrapped the whole project and we rebuilt it with Python and a graph database. So this is a picture of the CMS that we used for this graph database, and it's a small kind of corner of this very, very large decision tree. So why did we choose a graph database for triage? I would love to say that there was no hype involved in our decision, but the truth is that at the time, graph databases were all the rage. Even now, there's a lot of hype about it, and it's solving interesting problems, and we were keen to get our hands on this technology. But there are some good reasons that that a graph database is applicable for this use case. So in this decision tree, there's a massive sense of hierarchy. There's branches, sub-branches, sub-trees, etc. And this kind of data model is normally a good, probe that maybe a graph database will be applicable. The next thing is that a graph database has all the semantics we need to reason about a decision tree just out the box. Like that CMS that I showed you, we didn't kind of build that GUI ourselves. Like those were just like graph database semantics where you have nodes, relationships, relationships have directions, all these things that we have in our data model. So reasoning about, we didn't have to kind of build this mapping from like a relational database to our kind of, decision tree. And because the semantics kind of mostly match one-to-one, stuff like some of the tooling that comes out the box, really was really helpful without a lot of work on our side. The CMS being an example of that. So, what are some lessons learned? The first thing I would say, and this is kind of just true for all software technology, is new technology is try not get carried away by the hype, because when these new technologies come out, there's lots of attention, which means there's lots of hype on Twitter and etc. And if you make an uninformed decision on behalf of your company, it can end really badly. The second thing that I want to say is that, and this is specific to graph databases, is don't get carried away by the cool animations. Because I've never seen a technology that can sell its technology so well with such like really cool animations that looks like it's solving problems that you can't even imagine solving in your kind of traditional way of working. So when should you use graph databases? Now, the single most important question that you need to answer when considering whether or not to use a graph database is the following. Are relationships the most important part of my data model? Because if the answer to this question is maybe, or sometimes, or I suppose so, you're probably going to have a bad time. Because if relationships are the most important thing of your data model, there are just so much that you can do with a graph database. Now, the reason this question is important is because in traditional databases, like relational databases, relationships are represented or handled with joins. And joins can be expensive. And I use can there tentatively because there's many kinds of joins. There's hash joins and merge joins and index joins and other joins that I'm sure I don't know about. And databases have done a lot of work to optimize these processes. But to get the most out of it, you often find yourself writing kind of very specific queries that makes your data model kind of quite brittle, and the integration with your database quite brittle. Where with graph databases, because relationships are first-class citizens, as long as that remains true, you're going to have a wonderful time in graph databases. The second lesson we learned is that data modeling is extremely important. And this is very true in NoSQL databases, but especially true in graph databases. And we unfortunately learned this the hard way. So we did our medical triage with a graph database, but because that worked so well, we also decided to use a graph database for our chatbot data model. So what you can see here is a typical thing that you would find in our database. So the red node is a user, the green nodes are conversations, and the blue nodes are elements inside that conversation. And the element being basically everything that's in the conversation that is mostly messages between users, as well as like conversation status updates and stuff like that. Ignore the purple nodes, we'll just call those hack nodes for now. But what's wrong with this? So the first thing that's wrong with this, is you can't see it from the image, but the node most closest to the conversation node is the most recent element in the conversation. And at the end of the chain is the one furthest in the past. The reason why this is bad is that every time we add new elements to the conversation, there's multiple kind of operations happening. We have to delete the one relationship, change the status of the other relationship, then recreate another relationship, and it's just a really heavy and error-prone operation that happens. And not only that, is that it exposed some bugs in Neo4j, which at the time was, they fixed this, but at the time when you deleted relationships, it didn't clear up the disk space, and because we were deleting relationships like crazy, eventually our disk space just got used up. So what else is wrong with this? Also, you can't really see it here, but so the red nodes are users, and initially we wanted to represent the Babylon user, like the chatbot, as a user because it felt like correct. So everyone who comes into our chatbot, initially they'll be chatting to Babylon, like the chatbot user, and sometimes like a doctor will come into the conversation, But what this meant is that because most users were talking to Babylon, it meant that the Babylon user node had a relationship to every single conversation node. And what this means is that every conversation node in our entire graph database was only one node away from every other conversation. And in graph databases, this is called a supernode. And a supernode is like really bad. It's really bad for performance, and there's a bunch of ways you can do to get around this, but none of it feels good, and you really just don't want to go down that route. And all these kind of things we learned, like in production and stuff like that, which you really don't want to do. And we are way, way more hesitant now about adopting new technologies and making sure we do kind of proper investigation before we dive into something. So another reason why data modeling is important is because in graph databases, migrations are not trivial by a long shot. So what you see here is this should be one linear chain of elements in a conversation, just a user said this, Babylon said this, a user said this, it should be one chain. But what you can see here is that there's just craziness happening, like nodes responding with themselves and stuff like that. And this is a result of a cipher query. Someone committed a change to one of the queries and it just messed up the way that we were adding new elements to the conversation. And it was causing problems for users in production, so we had to fix it. Now, writing a migration script that fixes this is not easy because it's indeterminate and it's just really tricky. So you really want to pay a huge amount of attention to your data model so you don't ever find yourself in this kind of situation. So the third thing we learned is basically that the grass isn't always green on the other side. So so the medical triage is perfect for graph databases, but chatbot not so much. So we're basically migrating the chatbot data model over to Postgres. And as we're kind of coming back to Postgres, it kind of feels synonymous to the prodigal son returning, because we feel like we've kind of been over at Neo4j land promiscuous, and Postgres has just always been solid for us, hasn't done anything wrong. And we're returning now, and he's just greeting us with open arms. So stuff that we usually, felt restrictive now feel, so amazing. Stuff like constraints on your columns, they just like, blowing our mind. Stuff like familiar querying strategies and, sharding that is easy to do in relational databases. Database migrations are like amazing. All the tooling that comes around it, like SQL Alchemy and just the general tooling around Postgres and relational databases in Python, it's just so great to come back to all that stuff. So yes, the grass isn't always green on the other side. Okay, so we have medical triage. Brilliant. We launched it, it did really, really well. We pitched it against real-life A&E nurses and doctors, and it just did really, really well. We were really proud of it, and we kind of felt this massive sense of achievement. But as Ali reminded us, that we were still a long, long way away from where we wanted to be. So we knew we had to build a chatbot, and we have since found that building a chatbot is really difficult. And the reason it's really difficult is because natural language is really difficult. Natural language is like one of those problems that you approach the problem and you just imagine this is going to be hard. You have this idea in your head, this is going to be really difficult. But as soon as your skates touch the ice, you realize you've totally underestimated how difficult this is going to be. And the reason it's difficult is because the scope of it is just so huge. And you enter into it, you start solving one problem, and you realize, oh, well, this means this, and this means this, and next minute you're trying to fit the entire kind of semantics and linguistic rules and all the things that happens behind the scenes into your head and trying to solve that. And the biggest problem we had to overcome initially was figuring out how we could reduce the scope of natural language understanding to something that we could take a bite at and ship to production and serve our users. So, what did we have to do? So, the first realization we had to make is that we are not interested in helping you decide whether or not you should grow a man bun. Like, we aren't going to help you with that problem. We want to hone in on focusing on helping you with medical queries. So that's over there. Over here, we have a set of services. So we have this very well-performing medical triage. We have a bunch of content, content about different diseases and this massive library of content. We also have doctors who are ready to, if our machine can't handle your query, to handle your query. So we have this very kind of contained scope over here, and we have these services over here. So when we put it like that, all of a sudden it becomes a machine learning problem, because we have this infinite space of inputs, and then we have this kind of set of defined outcomes. And this is kind of called intent recognition. We wanted to take the input and map it to some output that we could do. If the mapping was not good, some generic fallback that would kind of redirect you to, ask us medical queries. So if it's a machine learning problem, then we need data, and medical data isn't easy to find. But we were really lucky because we already had this system running in production called Ask in our telemedicine application, where you could just send a single message to a doctor, and he would reply in a couple of hours with some kind of medical advice on what you should do. And the doctors and the nurses who were doing this had the good sense to tag each question and outcome. So we had thousands and thousands of these queries. So by the time that we realized we wanted to do this, we had this really, really rich data source, ready for us to train on. So, rich data source, some machine learning scientists and engineers, that's all you need, right? Not quite, because, what the inputs that were coming in were still free text. And free text is just inherently unstructured. So we had to figure out a way to take free text and then represent it in a way that our models could understand. And our machine learning guys did a bunch of work building multiple different classifiers to transform the free text into slightly different combinations. Some were just word in a bag, word to vec things. Other things were like medical entity extracted concepts passed into models. And then at the same time, they did some classifiers around our content and our outputs to make those easier to map. So essentially what they are trying to do is take a sentence and then put it somewhere on a map. And then the hope is that sentences that are very similar will kind of cluster together in this map. So it's very similar to a point on a map on some kind of 2D map. But the difference is that these maps with 380 dimensions. So this is like, a simplified kind of set with some test data. And what you can see is that in the top left, those red ones are all about your neck or something like that. On the right, we have some ones about hand and foot and stuff like that. In the middle, those queries are like ones about urination and pooing. I don't know what the politically correct way to say that is. but it's unclear to our models, like, is this about digestion, or is this about your abdomen, or reproduction, or anything. So there's some parts that are quite hairy, but you can see that some of the things cluster really well together. And the guys kind of iterated on their models, and it got to a place where it was doing really, really well. It was handling our queries with 95% accuracy and 99.8% safety. I'll explain a bit more about what those percentages mean in a bit. And they use a bunch of technology, a bunch of different technologies that are available to you when you code in Python. They use TensorFlow as well. They use a combination of RNNs and other deep nets. And I got to a place where they were really happy with their entity recognition classifiers. So we were doing really well. And we were taking some of these medical queries and we were just like knocking them out the park. We were handling them so well. But then we would get a really simple query and we would just totally bomb out. We would look so stupid. And then we would get another query that we just had an obligation not to miss. But we didn't really have good data for these queries. So the engineers told the machine learning guys to pipe down, they've had their time. We're just going to regex this problem. So we didn't quite do that. We used this tool called RiveScript, which essentially is this linguistic DSL that helps you kind of construct linguistic rules to catch huge variations of sentences and map them to a specific outcome. So this is an example. This is a query about, looks like some kind of abuse or child abuse or something like that. And it handles a huge variation of sentences in this one rule and then maps to a outcome that we want to provide to the users. So we wrote like hundreds and hundreds of these rules to kind of handle those like non-medical but kind of important queries. We're busy actually moving away from that now because the machine learning guys have had the chance to build things that are more generic, that don't need as much data and can handle these simple queries better than these rules can. So what did we learn? We learned that testing chatbots are really difficult. Since doing this, I've become really interested in how search engines test their search engine because you just have an infinite amount of inputs. Unlike a website where you have a bunch of buttons and it's only a certain amount of combinations, of how you can tap the buttons and stuff, and you can write comprehensive tests that make you really sure that your system is working. But if you have an infinite input space, you can make a change and not sure like what your change has done to some corner of this massive input space. So we couldn't come up with like a really good way to test, to give us huge assurance. So we just went for like many layers of testing. So the first thing we did was the model validations, which essentially is just putting some of your data aside as a test set, training your model on your training set, and then passing the test set back to your model to see how well it's doing. That's where the 95% accuracy comes from. We then wrote just thousands of RiveScript examples to test that linguistic DSL thing. So we just had many of these things. We also then created this kind of like client mock system that pretends it's a client, and with kind of BDD approach, just testing loads of different interactions throughout the chatbot. Before making major releases, we did clinical validation tests where we would get a big number of doctors into the office and they would use the chatbot, go through examples, and generate this report of how clinically safe it is. And we would then do post-market surveillance. So when the product is out there, we have some doctors who their main job is to take a sample each day and run through that example if they were handling that query, and then decide at the end whether or not this was safe or not. And that's where we get that 99.8% safety from. The second lesson we learned is that the chatbot is only as good as your content. So we initially thought natural language is going to be really difficult, and it is. And we spent huge effort into kind of solving that problem. But then when our first kind of, prototypes started coming out, we realized that this doesn't feel good. Even though our natural language understanding is really good, it didn't feel good because our content wasn't like optimized. We didn't spend that much effort in our content. And we've learned since that you need to kind of improve both at the same time, because good content without good understanding is really bad, but good understanding without good content is really bad as well. So we now kind of, as we're improving the ML stuff, we're also improving our content so that the whole chatbot becomes better altogether. And then I asked the machine learning guys, like, I'm doing this talk, what can I tell these guys that you guys have learned that doesn't give away the current cool things you're working on that is still kind of under IP control? And they said to me that basically standard classification doesn't scale in the way that we've done it here. And the sentence they told me to use is that information retrieval is better than classification. And the reason classification doesn't scale is because each time we want to make a small change, we have to retrain all our models, and sometimes the new feature we want to add doesn't quite fit with the way that we constructed those models, and it's just a very kind of slow process. We want to be able to iterate our chatbot really fast. So we have natural language and stuff, and we have the medical triage. We're doing really good, but we had no way yet to kind of communicate to mobile clients. So we had this really complex stuff happening in the back end, but we didn't have like this uniform way to communicate to our mobile clients. So we had the dispatcher is where, this is like a simplified, there's more services around this, but the dispatcher is where the understanding happens. We have leaflets and medical entity extraction services that it talks to, and we have the RiveScript DSL service. But we needed to build an API that kind of simplified all this complexity happening in the back end to a way that was consistent for our clients, our mobile clients, to understand. And again, this is just massively simplified. We have like 35 services running in production, but it's this kind of piece that was particularly difficult to kind of take all this complexity and map it into a simple way for our clients. And one of the lessons we learned is that just in this application was just an evil word, because we started off like, oh, we're going to build this chatbot, it's just going to be easy. It's just, request response. We can just use HTTP, it's perfect. But it wasn't quite like that, because we had to use WebSockets, and it wasn't just WebSockets. We had to also kind of bring APNS and GCM in there. And initially we were like, oh, it's just, one person talking to another person. It isn't just that, because there's other people, and there's doctors, and there's authorization of elements. And, our heads just exploded with how much more complex this was than we thought it was going to be. A really useful tool we used that, helped us, build and the clients build at the same time was Connection, which basically is this wrapper around Flask that helps you generate Swagger documentation that your code is dependent on, which means that your Swagger documentation is always up to date. So how it works is you basically build a Swagger YAML file. If you don't know what Swagger is like a standard for how API document or API design. So a standard way of representing what your API does. And you can do it in JSON or YAML. So you build your Swagger file. Connection then will map the endpoints on that Swagger file to the entry point in your code. And then it'll do lots of cool stuff for you. So this is an example of our conversation model. So you can see there's some strings and bools and arrays referencing to other objects. And then Connection will do that type validation for you that you don't have to do in your code. And it also means because Connection is doing that, you're really tied to making sure that this documentation is correct, because it's going to impact the way that your code runs, which meant that our documentation was always very, very good, which is very useful to our mobile clients. And what you get then is documentation, and not just documentation. You get an API client that your mobile clients can use to test out your API. Okay, so cool. So the last thing I want to talk about is just the role that Python played kind of in all of this. And I can really confidently say that we wouldn't have done as much as we did in the time we did it without something like Python. And some of the lessons we learned were like not surprising, but were like really welcomed and resoundingly true. And some of the lessons were quite difficult and not ideal. So one of the lessons we learned is that maths and Python are like a match made in heaven. There are just so many amazing tools that take really complex things and make them really easy, not easy, but make them really accessible. And then there's a huge community around this as well. And there's loads of tools and stuff on the internet and tutorials and stuff to kind of get you on board. So if you have like maths heavy workloads, Python is like an excellent choice for you. And not only that, Python and the web is also this really good combination, because again, you have all these amazing tools like everything from everything out the box frameworks like Django to more simple micro frameworks like Flask and kind of everything in between. You have like native support to all modern web technologies like Apache Spark and all the stuff like that. Database drivers and all that support is just really solid, which makes building the stuff really confident about building some of these complex systems. Some of the bad things we learned though is that if you have async heavy workloads in Python, you're probably going to get caught out at some stage. Even if you know what you're doing, there's probably going to be something that's going to catch you out because of all the kind of specific knowledge you need to know about how async works in Python. So this is a screenshot from Wireshark. And why were we doing packet sniffing, you might ask? No one wants to do this, but we had this issue where like 1 in 1,000 we were getting this SSL error that our load balancer was just throwing an error, and the SSL errors were different each time. And for the life of us, we couldn't figure out what was causing this problem. So we then went into the packets to figure out what was happening, and basically what's happening here is the server sends like a hello message to the other server. There's this kind of certificate key exchange and cipher spec and handshakes and stuff. And then right in the middle there, the server just says hello again. And the receiving the server is like, whoa, I wasn't expecting that, like fail. And we couldn't figure out why this like random kind of initial hello and the SSL handshake was just kind of getting in there. And we still don't really know exactly why, but we did find out that there's a compatibility issue with multiprocessing and eventlet, and eventlet was the underlying async framework that our web framework was using, and it was just causing some craziness. Another problem we ran into was when using AIO HTTP, was that once a week this kind of internal server we had running just kind of ran out of memory and crashed. And there were just some specific kind of implementation details that we didn't kind of completely read through or understand, where you had to kind of release the object, the response object if there was an error, otherwise the memory just kind of hangs around, and it's just this stuff that you really don't want to be dealing with. But when you're doing lots of async stuff in Python, you're probably going to find yourself dealing with these kind of like weird things every now and again. So the last thing I want to say, and I don't mean to be controversial at like a EuroPython thing, is don't look to Python for your like main sense of engineering achievement. So my relationship with Python is very much like an unstable romantic relationship, where I move from being infatuated to being totally in love on like a daily basis. Because I'll be using really cool stuff like generators and decorators and context managers and coroutines and all this stuff. but then I'll get something like this. So this is just a function that has a return and a yield statement in it. And if I was reading this for the first time, what I would imagine is that the yield statement will just get ignored and it'll just return 3 and everyone's happy and it all makes sense. But it doesn't do that. It becomes generator function and returns generator. So, okay, whatever, I can kind of live with that. But if you call next on this generator, I guess if I read this for the first time, I would imagine that maybe the return is skipped and it yields 2. But no, in fact, it raises stop iteration with the value of the return. And if you kind of go and read into there's a PEP for this, and it's got to do with coroutines and subgenerators and stuff like that. But to a new user, this just says return doesn't mean one thing in Python. And this is kind of it's stuff like this that I have to keep reminding myself that gives Python some of its characteristics, some of its personality. This is a quote from the Zen of Python, and essentially it says, practicality beats purity. And this is really important to us because we are way, way more concerned about making healthcare affordable and accessible than we are about doing it in the most pure way. And Python has that very same approach where it's way more interested in solving a problem and getting things done than it is about doing it in the most pure, special way, which is very different to when you go to Scala guys or Elixir guys and stuff like that. And with that approach, we've been able to build something that's really, really amazing and is affecting people's lives on a daily basis. And we're way more interested in that than we are about doing it in the most pure way. And Python allows us to kind of do that, which is something that is really amazing to us. So that's it from me. What's next for us? We're moving into diagnostic space. We're moving into a way more comprehensive health prediction and monitoring space. We're making our chatbot international, which I can tell you is not trivial. So like natural language for English is hard, natural language for Arabic is like, and Chinese like, so that's me. Are there any questions?
We have time for just one short question, please.
Really interesting talk. Did you, for your chatbot, take into account social situations or medical history of the patients asking a certain question? Because it can have a lot of influence on the questions the doctor will ask after he knows about the history of the patient or about his social context.
Sorry, I didn't quite catch the question.
For example, when a patient asks, I have a headache, what should I do? It can really matter if the patient is a young boy who goes...
Oh, right. So at the moment, let me think. So like maybe 2 months ago, no, but recently, yes. So recently we take demographics and age and gender all into account into the kind of outcome and path that you're going to take, that you're going to go through. And what we're working on now is not just to take that, but also taking everything we know about you. How many steps you're taking a day, the medication you take, all into the kind of advice that we're giving to you. And we have now a platform that we can start adding these more kind of complex reasoning and deductions to. So we're starting kind of down that path.
Thank you very much, William. Give him a big hand.
Yeah, sorry. I was trying to go faster at the end, but it didn't work.
It's okay. I'll show you the 5 minutes when it's almost 5 minutes to finish. Okay. What's your name?
Simi. Simi. Should I start? Okay. Hello, everyone. And today is the last day, so let's hope it's like this is my first EuroPython presentation. Let's hope I, do good. So this talk is about scientific computing using Python. So I'm gonna go around like some basic overview what Python is, how can you use it, and how can you specifically use it in the scientific computing world. So I am Simi Moria. I work at Credible Health. So it's a startup in India. So we work on like cancer reporting. So basically we work on like cancer detection in brain, liver, and lung. So the idea is to connect deep learning with cloud computing. So you can actually get all the matrices and dashboard directly through your web browser. So okay, you can't hear me? Okay, I'll be just near to the mic. Am I audible now? Yes. Okay, perfect. So what this talk is about, so we'll just go through step by step. What is Python? How we'll unleash the Python superpowers, and we'll try to build our first Python module, and we'll see how Python provides support for NumPy. And we'll unleash more superpowers, and there's a project demo at the end, CYVL Feat. So I worked on this project last summer for Portland State University. I actually wrote a wrapper for VL Feat. It's a library for computer vision. So it has all the major vision algorithms like SIFT and VGG, and similar to that. So okay. So what is Python? It's actually a static compiler for both Python programming language and the extended Python programming language. So it makes writing C extension for Python as easy as Python itself. So we'll unleash the superpowers now. So okay, the first superpower is you can, when you use Python, your Python code will actually be able to call C++ code back and forth. It talks to it natively. And you can easily tune Python code into, you can optimize the performance by adding static type declarations. Let's see how we do that. Yeah, so this is a pure Python code. It's a simple integration function. So yeah, it's pretty easy. So now you have to spot the differences here. So what do we have added? We have added a type to I, S, and DX. So we have pre-declared the types, and we have done that by using cdef and not simple def. So cdef is basically, there are actually three similar, so there is a def, there is a cdef, and there is a cpdef. So I'll explain it to them, I'll explain them later. Let's look at just cdef. So in a nutshell, cdef is basically when you're dealing with C stuff, and you don't have to deal with Python objects. So yeah, then that's when you use cdef, and that's, you'll be able to actually harness the actual performance of CPython runtime when you use cdef. So you have so you have defined the type of I, S, and DX, and how does it help? So whenever there is a performance critical code, you have to you have lots of loops and lots of computation. So you add static types, declarations. It actually allows actually Python just bypasses the CPython API calls, and it just runs everything in C. So the code that Python generates now, it's more, more optimized and has better performance. So typically how Python works is it's basically you write everything, in Python you write everything in .py file, in Python you write it in .pyx. So you can just copy paste pure Python code into a Python file .py, that is .pyx, and it would run. So this won't like give you like really good speed up, but you can do that. Like it's, if you want more optimization, you can actually include types, just as we did here. So just copying this particular code in .pyx gives like 35% speed improvement. So, and yeah, by adding some static types, it's actually like speed is like 4 times than as compared to the core Python. So yeah, I talked about def, cdef, and cpdef. Let's look them in detail. Def is basically, yeah, it's Python. So it is called directly from Python, and it takes Python objects arguments, and it returns a Python object. So there is no, you don't have to deal with C anywhere. So yeah, and cdef, it's basically C. So where Python functions, like you intend them to be like pure C functions, you want actual C performance, you use cdef, but you have to be very careful. You cannot like at that, when you are using cdef, you should, like that particular patch should not deal with any Python object. So that you might run into a problem if you do that. So the generated code, so when you compile .py, like Python file, it generates a .c, and then it it gets converted to .so, which is a shared object. So in Linux, and then you can directly import that SO in the Python session by doing an import, simple import. We'll come to that too. So cpdef, it's basically both def and cdef. So, there's a trick here. It actually recognizes both Python and C code. So when there is a C code, it recognizes, okay, it's C code. It can actually do some early binding. And when you're dealing with Python objects, so it uses dynamic binding, and yeah, it's kind of gets slow. So it's like Python then too. So yeah. It can directly import C, C++ libraries using C import. So you can just do C import, libc, something. You can directly import. I'll show you an example later. So yeah, you can actually integrate with existing C, C++ code. So you have, say you have a library in C, and you want to use it, like you want to create a Python interface for that library. You can do that by using Python. We'll look into that too, and just, unleashing all the superpowers. So yeah. Okay, so where's the magic? Like, how does Python do, what's so special about it? So the main feature in Python is the optional static type declarations. You don't have to declare them every time. They are optional. So the source code gets converted into like optimized C, C++ code. And this allows like very fast program execution with, programmer productivity, since you are using a Python-like syntax. So what's the motivation behind using Python? So this is a really cool diagram I borrowed from Advanced Python Summer School. It happened in 2012. So there's ease of use on y-axis, and there's a speed on x-axis. So speed, when you're using like low-level languages like Fortran or something, so they give you speed, and with Python you get ease of use. You want to find somewhere like a middle way out. So that's where Python is. Python exists. So okay, let's get to the code directly. So first one is Python core, second one is C, C++, or C, yeah. So third one is, Python version. So there's just few differences when you compare the Python and Python code. There's one cdef. This gives 80% speedx, and when you compare it to Python and like native Python code. So this is like a really sloppy function that I wrote. You can add few more optimizations. We'll come to that slowly. So Python, where is it used? So there are many big projects which use Python. One is NumPy, you might have heard of NumPy. And there is an AstroPy as well. It's not an example, but yeah, it does. And yeah, it's like coding in C and Python at the same time. Okay, we'll come to the use cases slowly. Am I going too fast? Just let me know if I am. Yeah, okay, thank you so much. So library wrapping. I have said enough, again and again, that you can wrap libraries. For example, I'll give you an example. So in C, when you're writing something in C, you have the structure is you have a .c and .h. In Python, you have .pyx and .pxd, the analogous files for those. And let's see how we can do that. Okay. So the second use case is when you have performance critical code. I have explained this already again and again. So the common procedure is when you really need speed, just, you can use a compile language like C, C++, and then wrap the whole code in Python. Instead of directly doing it in Python, it'll give you really good speed. And yes, the third use case is, okay, it's use case 1, I'm sorry. So who knows about the GIL? I think everybody does. Okay, that's great. So GIL is basically, it's a global interpreter lock. So what it does, it's kind of when the lock is acquired, it limits the thread performance. You won't be actually, even if you're running your program on a multi-core CPU, it won't be able to harness the power, the total power. So yeah, so there's a solution that Python provides to break out of the GIL wherever required. So let's see. So these are the unwritten rules of Python. You don't talk about GIL. You do not, and seriously, don't even mention the GIL. So let's get into an example. So this is this is a small function which actually keeps a CPU busy. So it does a lot of computation again and again. So it takes 6.7 seconds to run on my laptop. Now, this is a sequential one. There are no threads involved. This is a really simple function. Now, let's consider the threaded version. And yeah, there are 2 threads, and it takes 11.1 seconds. And this is not what you expect, right? So what happened? What happened here? Okay, so what happens is, when you run it on a multi-core CPU and multi-core processor, you actually expect the script to run nearly half time, or at least in the equal time as of the sequential version, but it's not happening because the threaded version suffers from a very bad behavior where the operating system tries to desperately schedule the 2 threads on different cores, but because of the GIL, the lock, only one runs at a time, and whereas the other is moved across the cores endlessly. It keeps, it tries to allocate it to any core, but it just can't. So that's how it takes so much time. So what's the solution? Python provides a really good context manager. It's known as with no GIL. So the catch is you can use it when it does not touch any Python object. So let's see how we can use it. So this is function, the implementation of the same function. It has different computation. It's a bit more time taking. So yeah, so we have this with no GIL, and you can see in the busy _ sleep _ no GIL. So we use this context manager with no GIL. So now you can see the last function. It's implemented in pure C because you're using CDEF everywhere. You're declaring all the types. So it's not Python. It's almost C. So the performance is actually increased so much, a lot. So let's see. Yeah, you can actually, you can use Jupyter notebooks to get these yellow. This is actually, when you use when you compile it using a -a flag, it creates this is yellow lines. The more yellow it is, the more Python interaction is happening. So you can see in line number 10, there is almost no Python interaction because yeah, you have declared everything. So this is super fast. And the number 1 and number 2 are equally yellow, so they are dealing with Python objects. somewhere, yeah, actually they are, that's why. So one tip that you can take is you can decrease the yellowness of these lines if you want to optimize your code. So that's one of your, like if you want to optimize, just use the -a flag and get these results and see where you can actually use, there is a need for optimization. So yeah, we'll build like a really small program. So I have, yeah, there's a lot, I have told you, like there's a pyx file and it gets converted to .c. And then .c is converted to .so or .pyd on Windows. And you can import it directly into a Python session. Let's see. You can import it, like you can build using different methods. You can use distutils. You can use piximport, and it's really cool tool, but you don't want to use it on production. I don't know. We don't use it. Third is Jupyter Notebook. Yeah, it's the most common way. That's the way I use it. So yeah, this is a simple hello world script. So you have a simple, this is actually Python. You can, as I told you, you can copy paste into a Python file and you can, it will run. So there's a line, from Python.build import Pythonize. It does all the work for you. It's like if you want to import it into the Python session, the Pythonize does all the work for you. So you use like extension module is equal to Pythonize, and that's where you're using your Python file, .pyx. So yeah, and when you use this -- in place, what it does, it creates a .so file in your current directory, so you can directly import it from there, and it would work. So yeah, congratulations, you have built your first Python, module. Yeah. Next, yeah, you can use piximport as well if you don't want to go through all that procedure of like writing a distutils and everything. You can just have a .pyx file somewhere, and you can just use piximport and import hello, and it would work. So it's a really easy way to do that. Okay, so what are the conclusions that we drive? Naive Python means when you just paste the Python code into the Python file. So it does speed up things, but it's not, you probably don't just, you didn't opt for Python to just get a like 1.8x increase. And so you probably might want to tweak it more. So you can optimize Python is where you have type declarations, where you are actually dealing with cdef and other modifications. So cpdef gives a really good improvement over def, but cdef is where actual power is. So it's really valuable, but you have to be very careful when you're using it. So Python cdef is it's almost equal to the C version of that Python code. It's the best attempt, like, to actually increase the performance, but yeah. Okay, now let's move slowly to the scientific computing world. So NumPy and Python. Actually, Python provides really fast access to NumPy arrays. So it has a C-level type, which is known as typed memory view. You might have, how many of you know memory? What's memory view? Okay, just 2, okay, anybody else? Okay, great. So memory view is it's like similar to buffer protocol. You don't have to you can actually read and get the contents of particular, say, array without memory view is just like an interface. You don't need to copy it somewhere, or you can just access it, you can read it. So the typed memory view is kind of similar to the NumPy array buffer support. And yeah, Python actually allows you to work with buffers without even knowing, without even getting into the details of it. So yeah, that's pretty cool. And a typed, okay, so because a typed memory view is actually designed to work with the buffer protocol, it kind of supports every buffer producing object efficiently, and yeah, so it allows sharing a buffer data without copying. So, okay, so we'll go, these are like Okay, so now when you have type memory views, the cat gets a unicycle. Let's see how we improve this unicycle, this mode of transport. So, okay. So let's suppose we want to work with like a one-dimensional buffer and in Python. So we do not care like how data is created at the Python level. We just want to access it in an efficient way. So let's create a def function in Python that has a typed memory view argument. There we go. So this double parentheses and a colon denotes a typed memory view. So you're actually passing a memory view as an argument to a function. So, okay, so yeah. And you might want to, so you can see there are a few optimizations like static type declarations. You are actually defining the types of I and total. Why do we do that? So I is actually the loop variable. So you probably want to like, you know, oh, we'll come to that later. Okay, I have a full explanation of that. So we are at, okay. So yeah, here the memory view actually attempts to access the object's underlying data buffer. So if the past object cannot provide a buffer, that is like, it might not, it doesn't support the protocol, then a value error would be raised. And if it does, then it means it supports the protocol. So this is actually, the next one is actually the same code, but with few more optimizations. You have tweaked more. So when you're iterating through a typed memory view, Python treats it as a general Python iterator. So it actually calls Python C API for every single access. So we can do better. So we were doing it here. We were actually, it's considered as a Python iterator. We are calling the API every time. So how can we do better here? So the typed memory views are designed in such a way that you don't have a Python overhead every time. So it's like, yeah, it's C-style. It's C-style way of accessing things. So this version has a much better performance. Probably if you make an array with like 1 million numbers, and if you want to add them and by doing iteration, and if you use this function, for that, it actually sums the argument. So if foo is an array of like 1,000 objects, 1,000 numbers, and if say it takes, say 2 milliseconds, this will take 1 less. I tried it, so I didn't include the example, so I thought I would explain it like this. There's one more thing. The Python, actually, in this case, Python generates a code that bypasses this Python C API calls and like indexes into the underlying buffer directly. So this is the source of our large speed up, but we can still do better always. So optimization never stops. It's a never-ending process. I learned it from Andrew. I attended his workshop yesterday, day before yesterday. So yeah. Okay, so now when you have this kind of speed up, our cat gets a good bicycle and it can do gymnastics. So yeah, it's a bit better improvement now. You can do a lot. You can actually increase the performance but you have to trade the safety. Let's see how. So every time we access our memory view, Python checks that the index is in bounds. So if it's out of bounds, Python raises an index error. Also, the Python allows us to index into memory views with negative indices. So just like the Python less, the index wraparound. So in our foo function here, we iterate through a memory view once, and we do not do anything fancy. It's just a rather simple thing. So we know ahead of time that we never going to index, we never index with an out of bounds or negative index condition. So we can actually instruct Python to turn off these bounce check for better performance. So to do so, we use the Python special module with the bounce check and wraparound compiler directives. So I have modified the code here. Yeah. So it's the same foo function. And now we have we have the original definition, but we have a new block or context manager here, which actually turns off the bounds and wraparound checking when we are accessing our memory view. The result is like really small performance improvement, but more better efficient code generation. It is up to us that we ensure that index doesn't go out of bounds. If it does, if you or you use like negative indexes, so you could lead into a segmentation fault. Yeah. So we can, okay, there are actually a lot of ways to turn off the bounds checking. So one way is this, you can use a context manager. If you just want to use it, see, it's the with bounds check false, wraparound false. This is just above the loop. It means that you want to turn off the bounds check for the next loop. So if you want to do it for the whole function, so you can, okay, no, sorry. Okay, yeah, this was it. So if you want to do it for the whole function, you can use this another, actually you can use a decorator. So it's another form of directive that removes the context manager. So there's one more way if you want to like remove the bounds check like globally across the program. So you can use another compiler directive. You can actually add it's a comment line where bounds check is equal to false, and same for the wraparound. So this actually now the Cython provides like different scope levels for these directives. One was context manager, second was decorator. This is like global module level. So you can actually have like really precise control over like where these directives are in effect. So they can be easily disabled and for debugging and yeah, and enabled for the production runs. So yeah, now your cat can do this. Like it has on a like big rocket and it has laser beams in the eyes. And it can, okay, it can also do this. It's up to you how much you want to optimize. Okay. So I promised that I'll show you a project demo. Okay, so let's just wrap up like what have we learned. So we saw how to declare like a simple typed memory view. We saw how like indexing a typed memory view within, you know, integral argument can efficiently access the memory view's underlying buffer. We saw how to use the bounds check and the wraparound directives, and we saw like 3 different ways. So, so when do we optimize? Like we just don't go and optimize everything. So I borrowed this from Andrew's tutorial again. So you first see, like you have to actually profile and you have to set benchmarks, like, okay, where do you want to optimize? You just have, so there are some, if you want to like write a really small program, you probably don't need optimization. You have to like know beforehand whether you need it or not. Now you know it. You can use the -a tool that I told you earlier. So now you know where the optimization is needed. So you can go ahead and like add static type declarations or any of the previous method that I told. Yeah. Next, okay, so this is the project demo. Last year I worked for Portland State University for Google Summer of Code program. So the project is C by VLFeat. It's actually a wrapper for a library named VLFeat. So VLFeat is actually, so what is VLFeat? So VLFeat is actually popular computer vision algorithms library. It actually specializes in image understanding and local feature extraction and matching. So we have like a couple of algorithms you might know, the SIFT, scale invariant feature transform, k-means, hierarchical k-means, and slick superpixels, and quick shift superpixels. These are like very famous image algorithms. So yeah, these are the algorithms that it has. So I worked for a company in like India. So they needed to, they were working on a video platform. So what they were trying to do, there was actually, so if you see a video and say someone is driving a car and you love that car and you want to know which model is that, or like probably the video is really short and you're not able to get, spot the like, you know, brand of that car. So they were actually trying to make a video advertising platform. So where you can, it provides you, you know, an interface to run the video where you can actually click on any pixel. So if that pixel belongs to a car, that clicks got saved somewhere, and you can see it when the video finishes, or probably in the middle. So it saves, actually each and every pixel was labeled, and it was mapped to the advertisement info. So if that car, if that car was like Ford Figo, you can actually see it, and that you can directly go to the advertiser website or something. So we were, so there was a lot of object detection involved in that project. So I had to use VLFeet. So it was like written in MATLAB, and so like, you know, companies don't prefer MATLAB, so they asked me to like whether you can write few functions, like you can wrap few functions for for Python. So I proposed this project for Google Summer of Code last year, and it got accepted. And so project was already in. I didn't realize this, but the project was already in progress by like 5 researchers of Imperial College of London. They were already working on it, so I contributed along with them. So we worked on like 14, 15 features, and they got completed. So yeah, yay. So you can find it here. It's CYVLFeet is a part of MENPO project, and MENPO was actually in the demo section of last year CVPR, the computer vision pattern recognition workshop last year. So you can check it. It's a small part of the big MENPO project. So yeah, contributions are welcome for CYVLFeet. You can actually fork it and create a new feature branch. So I'll also tell you a few limitations of Python that I faced when I was working on the project. So yeah, by the way, yeah, these are the 2 modules that need more work, and these branches are like still really active. You can go through, have a look or something. I was actually working when I was wrapping this particular library, VLFeet. So there's actually the BinSum module that you can see. It has, we were actually taking reference from the corresponding MATLAB interface. They had a MATLAB interface. So there was like, in MATLAB, the structure is quite simple. So there's, when you have a .h file and a MEX, which actually provides, there's a MEX file which actually provides the interface between MATLAB or Octave, and the functions in like MATLAB and C. The MEX files do that. And so the corresponding Python implementation would have been .h translate to .pxd, and the CMEX translates to .pyx. So that's the analogous. So there were no deviations until we finished like 12, 13 features. But when we came to BinSum, there was a file .def, which is the module definition file. So, I'll give you a brief introduction what def is. Does anybody know here what .def is? Okay, it's okay. So, in Windows, .def describes what functions are going to be exported from the DLL. So unlike in GCC Linux, where every symbol gets exported by default, so you have to tell, in Windows, you have to tell the compiler what functions to export. So the standard way of doing it is to write .def files. So at that time, I didn't know how to wrap this def file in Python, what's the analogous. It wasn't documented anywhere. So yeah, I asked, it's on Stack Overflow, that's the normal way of doing. So yeah, I still can't figure it out. If somebody knows, you can just talk to me later. So this is the one limitation that I faced with Python. And there's one more limitation in Python 3, they have removed the nested tuple argument unpacking. So yeah, Python also doesn't support that. So it's a recent removal. The slides are here if you want to download it or something. Thank you. Yeah, I finished it really early. Okay. Okay. So any questions or something?
We have time for a lot of questions.
Okay.
Thank you so much. It's a great talk, and well, personally, I'm going to rate it highly.
Okay.
Yes. I have a question. Do you have any examples of importing or referencing external libraries from Python? Yes.
Okay, let's go. Here we have. So you see this one, can you see it? C import libc.math. So you can directly import the library and see. Okay, there's an example of -a as well. So here it generates, okay, you can actually click on it. Yeah. So this is the C code that it generates. So yeah, you should be able to read it if you want to optimize it. So yeah, it takes some time. So it's number 4 is a bit less yellow since it deals with the direct like C library that is imported directly from C. So yeah, it's a really small, yeah. And that number 3, it deals with Python, the def. So here it's a bit longer. Yeah. Is it clear?
Any more questions?
Anything else? Okay. Thank you so much. Okay.
Give her a big hand.
Do we have? Do we have? Do we have other questions? Do we have other questions?
No.
Okay. Thank you.
Humans, welcome. Now we have Michele Simeonato, lessons learned in X years of parallel programming. Give him a big hand.
Thank you very much. It's always nice to be at the EuroPython. Actually, I'm a long-time Pythonista. I started 15 years ago, 2002. The reason of the X in the title here is this X. I'm not sure how many years I've been doing parallel programming because I learned about it the first time 15 years ago. Then more or less 10 years ago, I worked in a company where we had the cluster. So I was doing parallel computing, but was not real. I would not consider I was doing really parallel computing because we were just. I was just writing sequential code, and the cluster was doing everything for me. But now, in the recent years, let's say 5 years ago, I've been working for this GEM Foundation, which is a global earthquake model, and we talk about it briefly. And here I'm really in charge of how to parallelize the algorithms to compute, to simulate earthquakes, things like that. And so in these last years, I really been doing parallel computing a lot. So I learned some lessons that I would like to share with you. So this is a picture that shows what we produce at the end. This is a map of the earthquakes that may happen in the next 10,000 years in California around San Francisco. You see, magnitude, things like that. So we do this kind of plots. Also, we do estimates of the damage these earthquakes can produce. And we have a number of sponsors. And you see that there are two reasons why I'm showing this slide. One, the sponsors are giving us money, so I'm here even because of the sponsor, thanks to them. And the second reason is that even you can be a sponsor because, okay, here you see big names like you see big, typically reinsurance companies, or you see states like Australia, New Zealand, Taiwan, Switzerland, United Kingdom, Italy, Germany, Japan, several countries. And USA is giving us a lot of money because also we have projects with third world countries. I don't know, Tanzania, Africa. We have also worked with South America, Central America, Kyrgyzstan. It's very difficult to find a place in the world where we do not have in collaboration. So there are big names here, but I'm saying that you can collaborate with GEM even if you don't give us money. But if you want to give us, I don't know, free access to computing resources, or if you are Intel, you want to give us software licenses or hardware to test, you can help and you can contribute. This is no-profit foundation. So it's also ethically good because you contribute to save people in a way. So that was my introduction. I personally work on the OpenQuake engine, which is our computational engine. GEM is not only about the engine. There are several other things that we do. We have a scientific staff. Actually, I'm the IT guy. Originally, I am a scientist. I'm a physicist, but I didn't do anything at all with earthquakes, so I'm not an expert on earthquakes. Please don't ask questions about earthquakes. But I'm saying that we have other things that we do, and there are some colleagues of mine here too. You can recognize them, at least one of them, because of this picture with the OQ logo, okay, like OpenQuake. And other things that we do, for instance, that guy here, my colleague, is doing the visualization part. So he has written a QGIS plugin to plot the result of the engine, to do analysis of what happens after an earthquake, how much time it takes to recover, things like that. And they have another colleague there. He's working on the platform because also we have a web platform based on GeoNode where you can share maps, download data, things like that. So lots of things. In the engine in particular is a mature project, I would say, because it started 2009, so 8 years ago. I have been working on that more or less 4 years and a half, nearly 5. So it started before my time. So it has all the good buzzwords. So it's on GitHub. We use Travis, we use Jenkins. We support Python 3 too. We also actually we have a plan to drop the support to Python 2 next year. And there is also a small part, which is there is a web interface, so there is a small part which is web, but it's really small. Really, most of it is the computational part. We focus a lot on the scalability. So this engine works on a Raspberry Pi, works on an Atom, works on your laptop, works on a workstation, works on a server, works on a cluster, and we believe it also works on a supercomputer, but we don't have access to a supercomputer. So if you want to start a collaboration with us, we are open. Okay, this was the introduction. And now we start the real talk. This is not my laptop, so because of projector issues. So accept the fact that I didn't want, I wanted to show a demo, but since it's not my laptop, I always keep on that. So this talk will be not, will say nothing about earthquakes. Earthquakes. I want to be more general because I expect here people are, most of you are programmers, not necessarily very versed in numerical simulations. And my point here that parallelism can be useful even to people that they don't think that it is useful. They are not doing numerical works. So this, the reason why it is very useful because these kind of problems, which are called embarrassing parallel problems, are extremely common. So anytime you have some data, you want to process some data, and you can split the data in chunks and apply the same argument to each chunk, that's a parallel problem. And there is also a good support in the Python world to solve them, so it can be even easier than you think. You don't need to be a computer scientist. And there are also some tricky points that make this fun. So I will give you a motivating example here. It's very simple. It also comes from real life, because before coming to GEM, I was working for a finance company, and I was a back-end engineer, and I did several things, but among them, I was in charge of importing data in our Postgres database. The data were essentially CSV files with these structures. There were code for each financial security, the date, the price at that date. Very, very, very simple. The problem that we had thousands of files, hundreds of thousands of different options, financial securities of different kinds, and we were going to import, I don't know, 60 million rows in Postgres or something like that. And the issue, this was an issue because we had a process where we were importing the new data and then compute the prices of the derivative financial instruments, and during the night. So the night is, I don't know, 8 hours on night. If you can import things in 2 hours or 3 hours, then you have 5 hours to do the computation. But if the importer is too slow, you don't have enough time to do the computation, and you cannot provide your users with the data, with the output they want. So we had this problem. I was thinking how we can speed up the import. And one idea could be, okay, I would do this import in parallel, but I was not very convinced that this was a good idea, because at the end, you know, you have one disk, everything is imported in the same database, where there were no sharding, no sophisticated things. So I was not convinced that parallelism was going to help. On the other hand, you know that Postgres is able to make use of all the processors that you have. So we have the server processor, why to waste them? So let's do some experiment. So think again. So the final messages I'm going to give you is that actually this looks like an I/O bound problem, but actually the parallelism can help a lot. So this is a demo I wanted to do. The demo that I wanted to do, I was producing 500 files, more or less. Each file has 10,000 rows, and there are more or less 5 million rows and 200 megabytes of CSV to import. This is an example. Actually, we had a much bigger thing, but this is an example I could run on my laptop. And okay, and I'm not doing any magic here, except that I'm not regenerating the indices, because probably you know if you have worked with this kind of repositories, that the best way if you want to import stuff is to drop the indices, import everything, and then restore the indices. And maybe restoring the indices takes more time than importing if you do it that way. So how much time do you think it will take to import 5 million of rows, okay, of prices? On this laptop, which is a very old laptop, is actually 6 years old, is a ThinkPad, 12 inches, is not a workstation, it's very small. So the idea was to do the demo here, but I don't do that on a computer which is not mine. So, but I can give you the answer. You may think, oh, 5 million rows, I don't know, 5 hours, 5 minutes, 5 seconds. Can you raise your hands? How much do you think? 5 hours? Who says 5 hours? Nobody. Who says 5 minutes? Who says 5 seconds? Sequentially, somebody 5 seconds, 5 minutes. Actually, you are right, because it takes essentially 1 minute on this laptop, which is really impressive. If you think 5 million rows in one minute, it's really impressive. So it is fast, even sequentially. This is the code I'm using, if you are curious. Of course, I'm using a copy from, which is the right way to do if you have to import CSV. And I'm doing things sequentially. In this example, I'm printing how much time it takes. Okay. So I have a first line here where I call PSQL, and this db.sql is a file where there is a create table, essentially. So I create the table, and then I look inside this directory where I have my data. So I loop, which are the CSV files. I loop all over the CSV files, and then I call this map function, which is just doing the copy from, calling PSQL. So for each file, I'm starting again the PSQL command, so which is not the most efficient way you can imagine. You could do everything in Python, but still, if you think that the startup time of PSQL is small, the file is big enough, let's try it. In this way, you can do it in 1 minute. Okay. Now, suppose I want to do this in parallel to see if there is an improvement or not. So to parallelize is extremely easy. You know that the Python standard library has a multiprocessing module, from which you can instantiate a pool, and then there is a command pool map that I assume most of you already knows. Somebody does not know about the multiprocessing pool? No, yeah, so everybody knows it. So it is easy. Maybe you don't know that in multiprocessing there is also a dummy module, and if you use this dummy module, you get a thread pool instead of a process pool, so you avoid the penalty of instantiating a pool of processes. You just use a pool of threads. In this case, it's fine, but then the processes are actually the PSQL processes. So you can do that. Very simple. And how much it takes? It takes 21 seconds, so it's 3 times faster on this machine. This is a machine which is a dual-core processor. There is hyper-threading. So they look like 4 processors, but if you have done this kind of things, you know that the real threads are the important ones. So the fact that, so I should get, if this was dominated by CPU, I should get a factor of 2 speed up, not a factor of 4. Instead, I have a factor of 3, means that there is something strange here. There's some things are dominated by the disk, some things are, there is some CPU parts, which is not. And you can do a lot of exercise of this kind. These are exercises that I'm suggesting that you think about. So What happens if you have short CSV files? You can think that the files are so small that the startup time to start the PSQL external command may kill your performance. So maybe instead you want to use PsychoPG and access directly the database from Python. Then you have a copy from also in PsychoPG, use that. Then you can think about if I do this concurrently, how does it work? Because the Postgres has the possibility of instantiating one connection for each thread or one cursor for each thread, which is the most efficient. Or what happens if you use processes instead of threads? How much this depends on the hardware? Because I was very surprised that this old laptop takes 1 minute. In my office, I have a new workstation with 10 cores, very powerful. It takes 80 seconds, so it's lower the big machine than the small laptop. So there are all kinds of strange things that may happen. And also, if you try something with one version of the software, it is very slow, you think, this approach will fail. Maybe after 6 months, a new version of the same software appears, and then immediately becomes fast, what you thought it was slow. So it's very tricky. And what you really absolutely need to do is to measure. So you need to have a way to measure, to instrument your code, your specific use case, and see how fast it is, depending on all these kind of circumstances. This is the most important thing. And I want to show you how we do that gem with the OpenQuake libraries. Just to give you a suggestion on how the monitoring we do works. I'm not saying this is the best monitoring in the world, but it's really good for what we are doing. So essentially, you have to import a monitor object, which is a context manager. Then you do with monitor, and you monitor a piece of code. This will time at the start, at the end of the code. Also, we measure the memory occupation, how much memory is instantiated in that block of code. We have a star map class that actually you use like the star map in EtherTool star map on, or also in pool star map. There is a pool star map in Python 3, where essentially you map a function on a list of tuples. This list of tuples can be an iterable, so an iterable, etc. However, this is just a thin wrapper to abstract away the concurrency layer. Underlined, we can use res, processes, we can use celery, we can use any kind of, a lot of kind of different frameworks of concurrency. But this way is homogeneous. Depending on a configuration variable, or you can use one way or the other. And also we have, we like very much the HDF5 format, which is really, really good if you have, if you need high performance, if you have arrays, lots of numbers to store. We really like the HDF5 format. So we store the performance information inside the HDF5. In the past, we stored directly inside the Postgres, so now we are storing this. Okay, anyway. So the function that does the real job, import data, is the same as before, except there is an additional argument. So the last argument is the monitor. So you want to, this is the instrumentation part. Then you instantiate a monitor. You give to the monitor the path to the HDF5 file where you will store the results. Actually, we have a convention that there is a directory in your home which is called QData, and then it will generate a file with a number like calc1 HDF5, calc2 HDF5. Every time you run a new calculation, we will produce a new file. And these are the arguments that you want to pass, which are the name of the file and an instance of the monitor, and you do your computation. And it will be fast as before, because essentially, by default, it will use a process pool. This is underlying, on a single machine, you are using the concurrent futures module. And so by default, it will spawn Python processes, but you can also spawn processes if you want. This is an environment variable. You can use celery. You can also say no, it means do not distribute, which is really important if you want to debug something, because if you have an error, You put OQ distribute equal no, run your calculation, put a Python debugger inside and see what's happening. So that's very important. And we have others. For instance, we have an experimental implementation that works with a grid engine. But I have only tried it on my machine, and we don't have a supercomputer to do that. But in principle, in any place where you have a kind of map concurrency framework, we can easily extend. So I was saying this is doing a lot more than just using pool star map that we have in the standard library. And we have commands there where we can see the performance information. We can see for each task how long it took. We can plot the length of the times of the tasks, see if there are, for instance, slow tasks. This is a very common problem that we have sometimes. One task is so slow that it dominates the computation. Everybody is waiting for that slow task. And another very important thing that it gives you the measure of how many bytes you are sending to the wire and how much bytes you are receiving. This is very important when you are in a cluster situation because there are limits. So it can happen that your calculation fails because the data transfer is too big, so there is an error, it fails. Maybe it does not fail, but still becomes slow, or you have memory issues, things like that. So you have all this kind of useful information. Another nice thing that this approach does not require you to decorate the task function. I don't know if you are familiar with Celery or with other concurrency framework, you typically have to put a decorator. With this, you don't need to put a decorator. You can even run in parallel a function from a third-party module where you do not have access to the source, so you can change it from in. So it's nice. And of course, the OpenQuay libraries, we spent several years working on them, so we know the trick, so the problem. So if there is an error, one task fails, you get the traceback, everything shut down properly. For instance, one problem, if you are on a single machine and you kill the parent process with multiprocessing, the children stay alive, which is really annoying. But we can work around that because there is a library which is this process control, which works on Linux, which automatically will kill the children if the parent dies. Another trick that we use is that we fork the process before loading the data, because if you have, I don't know, 5 gigabytes of data, you first read the 5 gigabytes, then fork, maybe you have 10 cores, you will consume 50 gigabytes of memory, so it's best to fork before. There is also suicide functionality in the sense that if you measure how much memory you are available, if you are already, I don't know, 98% of the available memory and you don't produce no task, you die. So there are things like that. We also found problem with the libraries we were using. So for instance, in Celery, they have this feature that once you do a calculation and the task returns a result, all the results are kept in memory, are cached. So if I am returning 100 gigabytes of data, my cache is 100 gigabytes, so you see a linear increase on memory, and then you run out of memory, you die. So we have to do some trick to avoid that, so essentially touching a private method of Celery to do the right, what for us is the right thing. For them is the feature, because Celery is meant for, not really for numerical calculations. Anyway, we are using Celery because of historical reason was not the decision the current team did, comes from the past, but it works enough once you know the tricks. There are situations when it does not work. So I don't think it will stay for us forever, but for the moment it's still there. So, and we have other things interesting, like there is a SQLite database which stores all the metadata for the informations and the metadata for the calculations, metadata like when the calculation started, when the calculation finished, who started the calculation, so users, things like that. And we can dump and restore database. It means also because calculation an HDF file, we can copy those files, so we can delete lots of things. And there are facilities to convert from Python objects to HDF5 objects that you can store. But we have also things like reading seismic sources from XML, but the library is totally generic, and you can use this as a generic serialization library from Python to XML, both in read and write. We have some data structure. This is an accumulation dictionary, which is convenient. Typically, we have a dictionary of arrays. So we return back these dictionary arrays, then you can sum these arrays or aggregate in different ways easily. So there are things which are useful. So you may think, well, then, okay, I will go and download the engine, and I recommend you to do that. Yeah, you can. It's free. It's on GitHub. You can install now very easily, on any or Mac, Windows, Linux. Very easy, but I must warn you that this is a framework. And if you know me, you know that I'm not particularly in love with frameworks. I mean, there are people that, like in the keynote, say, oh, Django is really wonderful. And yeah, I agree, maybe for their use case, it's very wonderful. But for my experience was that whenever I had a framework, I was always fighting against the frameworks because I needed to do something that was slightly different. So, you know, I started with Plone. So if you have worked on that, you know my pain. So, no, I'm joking, but not so much. So it's very good if you write your own framework. I think you must write your own framework for your job, for your application. But think twice before shipping it, okay? Think twice, because I don't know any good, any web framework that I think it is good. Not even one of them. I like it really. So my idea here is to ship you the idea. I want you to take this idea from the engine, look at the code. The parallelization part is very small, it's a few hundreds of lines. Maybe copy. Still is fine, you can. If you really want also to use the code, you can, but it's an Affero GPL license, you can. And this is the documentation. You can click on this. I don't know, I'm not sure if the interconnection works, so I will not click on that. But you can do all of these things. So now, very quickly, I want to give you some lessons that we learned. One very important lesson that you have to do the real calculation. So a small example is good, is nice, but when you scale up, you will find problems. So always think twice before believing a trivial example. Like, for instance, this example of the database import is totally different if you start from an empty database. Here I was starting from an empty database. But if you start with a database which is already filled with, I don't know, millions of rows, the performance is very different, okay? Also, it depends. If on my laptop I have 4 processes, I have 4 connections to Postgres, works, but there is a limit to the number of connections that Postgres can take. So if I don't remember if the limit is 256 or 500 or 12, you can tune it, you can configure it, but in the past, we ran over that limit, the compilation just did not work. So maybe even if you are under the limit, it will work, but maybe there is context switching, contention of resources, and things will become immediately slow. So don't trust the small example. This is the first thing. Another very important lesson is data transfer is very important. Memory, when you unpickle things, you need a lot of memory, so you can, and it's difficult to measure the memory you spend in pickling and unpickling. So be careful about that. The best advice is to use NumPy arrays everywhere, especially when you have transferring things, transfer NumPy arrays. And also another surprising thing is that running out of memory in some sense is good, because I can have an algorithm which does not run out of memory, but it takes forever. So my scientist comes, runs his calculation, this takes forever, 1 week, 2 weeks, 1 month, we don't know what's happening. So it's a lot better if this runs automatically after 1 hour, so the scientist look at this file and says, this parameter was wrong, sorry, I have to change, so they will have a plan B, they will fix it. So but it's important that you give information early. And also, a wrong algorithm, if simple, I discovered that it's better than a correct algorithm, which is complex and slow. Because if you have something which is simple and fast, yeah, even if it is wrong, you fix it. It's simple, easy to fix. But if you have something which is complex and slow, you cannot make it fast because it's so complex you don't know what to do. So really, at the beginning, I was doing some change. I say, well, I do this change, then I will fix all of my tests. I will spend hours, days to fix all of my tests. Then I will put this in production. No, in production, no, but in testing, I will discover that actually this change worked on my machine, but not on the cluster. Now I'm doing differently. I'm saying, okay, I will do this algorithm. I will not do make green all of the tests, so I know it is wrong in some cases, but I don't care. I put this in testing as soon as possible. I see the performance. If the performance is good, then I fix all the other tests and continue. But if the performance is bad, okay, I change approach. This did not work. That's the end. So other things that, and now I'm finished, I'm open to questions. I should have a few minutes for that. It is very good to have a concurrency layer which is independent for the parallelization technology you have, because you want to try, you want to see what happens if I use threads, what happens if I use processes, what happens with this and that, if I remove, it's important. And also we have a very, very simple approach to concurrency, which is this map. Because I had something more complicated before, but after I saw the EuroPython last year, I went to the high-performance computing training. They saw they were only using map, so I said, well, also, in reality, we only need the map. So I removed the featured mode that they had. Yeah, another thing is that, if you have problems with the data transfer, as we have, maybe instead of sending this data across the wire, maybe it's best if you read them, because we discovered the performance of reading, for instance, from a shared file system was a lot better. Also, if you read from a shared file system, you read directly the array from the HDF5 file. You don't need to unpick all that. So it's much better to read. On the other hand, you don't want to write directly from the worker or something, because you can easily get bottlenecks, things like that. So. And also another very surprising thing for me that I thought, okay, now I'm going to do high-performance computing. I will be using the Python profiler all of the time. Instead, actually, I use the Python profiler, I don't know, 1, 2 per year. Sometimes you need that, because since 1 month ago, I had a problem that I did a small change, everything was slow. I had to use the Python profiler to discover why. But the reality is that 99% I don't use the Python profiler, because our problems are more to do with data transfer, pickle, the way the arrays are stored, how to store the arrays, the length of arrays, things like that. So, and this kind of information I get from the instrumentation that we wrote. So that's the final lesson of this talk. Now I'm finishing. Think about instrumenting your system, and write your own instrumentation, because only you know where is the right place where you can get information and information you need. And that's all.
Thanks, Michele. Any more questions? Apparently not. Give him a big hand.
Don't be scared. I think somebody here is scared, but we will be available for lunch. If you see me or people with this kind of T-shirt, ask us. And even at the coffee break, but then after 3:30, we will leave, unfortunately. So if you have questions, ask them now. Thank you.
Session of the afternoon, the first talk of the first session of the last afternoon. And we are going to have Armin, and he's going to talk about PyPy, Python 3, NumPy. Give him a very warm round of applause, please.
Thank you. Thank you. So, I'm going to give you basically what is 5 lightning talks end to end, because I'm going to present you what is new in PyPy, what's new mostly from last year, and well, a lot of small things are new, small in quotes. So what is PyPy first? PyPy is another implementation of Python. I guess you kind of know that if you're here in my talk. It's mostly a drop-in replacement, which means, well, you have this project that use CPython. You start with Python foo.py. Then, well, you can start with PyPy foo.py, and it should work the same way. So far, PyPy supports Python, the language, version 2.7. Now, in these few months, it's about to support Python 3.5, the language. And, well, the advantage, why would you use PyPy instead of CPython? The most common reason is just performance. There are a lot of programs that are just much faster on PyPy. Okay, so first let's talk about PyPy 3.5. So it's Python 3.5 support, which is released in, well, beta was the name I wanted to say. I was told that maybe I should use another name, so I'm using Gamma instead. So why is beta not a good name? Because it works, because it's very stable, and it's very fast and everything, but it could be wrong in a few details everywhere, which means it's probably missing some functions in the socket module. This new socket method there is not implemented, or this new extra keyword argument of that function over here is not implemented. It's this kind of thing that is not done yet. But it is there, and it works. And it's fast. So the current status is please try it and report issues if you're actually finding this kind of missing functionalities, because it's not like just by running the CPython test suite we find most of the missing functions, but not all of them. So a special thank you goes to Mozilla, because Mozilla has actually been giving us a big grant, like 4 people 1 year, to do this work of Python 3.5. And this is just a set of benchmarks running on Python on PyPy 3.5. This is just benchmarks for the new keywords async and await on 3.5. Which, well, basically it shows that it's fast. The red lines are speed in requests per second on PyPy, and the blue lines are on Python. And it's async, AEO HTTP, G-Event, Tornado Web, Cur.io, and H11. And on the right, Twisted and Klein. So it's fast, cool. I should mention for completeness that this doesn't, I mean, if you are writing an async HTTP and you are writing it for performance on CPython, then you would probably not use any of these, but instead use things like the libuv, which is pretty fast on CPython, but which is not included here because it's all C, basically. This is these plots are more about the performance of pure Python code. Okay, the status, it's roughly complete. So complete 3.5 support plus the F strings, which is a new feature in 3.6, but which we also added into 3.5 because why not? And because people tend to like this feature. Okay, it has good performance. It is tested mostly on Linux only so far, which means that some Windows or OS X specific interface are probably missing. The first final version, I mean the first version that will not be called beta or gamma or whatever, will be released like soon. And once we get there, then I'm confident that we'll continue and progress to Python 3.6 and probably 3.7 next year, etc. Okay, so this was my first lightning talk. The second one is about scientific stack. So if you are using the scientific stack, you are using, well, first NumPy. So the news, so what is new from last year, well, first it's that, well, there are two different kind of modules that you can use inside PyPy. One is NumPy, that's the standard version of NumPy that you download with pip install NumPy. And there is another one called NumPy, which is a built-in module on PyPy, and which is not complete. So what we did is basically this. NumPy is deprecated, don't use this anymore. Instead, just use the standard NumPy. So what we did is to support enough of the C layer, the C Python C API layer, in order to be able to run NumPy. So the end result is that NumPy really works. I mean, it's here I put 99.9% because there are 2 failing tests out of the thousands and thousands, and there are bad dog strings or something. So another interesting bit is that it works on PyPy, the standard PyPy that implements Python 2, but also on top of the PyPy that implements Python 3, 3.5 in this case. Okay, and well, from these points, you can actually build on top of it, and things mostly work. As in, you can run Jupyter, Matplotlib, Pandas, etc., and all this package mostly work in PyPy. So here is an example that is not at all impressive, but so it's a standard Jupyter notebook, and I can run this, and I get Matplotlib. I get Matplotlib to print me. Oops, sorry. I got Matplotlib to print me this nice graph. So, well, the only thing here is that it happens to be running inside PyPy 2.7. It would work just as well inside PyPy 3.5. So it works. Cool. Yes. Okay, so what I said about the C Python C extension is more generally, if all Python modules work, or more generally, any C Python C extension module mostly works nowadays out of the box on PyPy. So this is all thanks to CPyX, which is our own C Python C API re-implementation or emulation. So, well, yes, it's an emulation, which means that it is bit slow. So it means it is slower to run all this NumPy and the complete scientific stack. If you run this and compare the performance with the performance that you would get on top of CPython, you will find that PyPy is slower. So less so than up to last year, but still slower. Well, there are workarounds. here, so I mean, what is slow is really the boundary between Python and C. So for instance, if you are doing a lot, if in your program you happen to be doing quite a lot of array indexing, it's slow, because every single array indexing is going to cross this boundary. On the other hand, if what you are using NumPy for is computing the eigenvectors of one huge matrix, then it's a complex and lengthy process, which is just as fast because you cross the Python C boundary exactly once. And well, so far there is this speed hack here that, well, don't use it basically, but it's very good right now. You take your ND array, you consider it as a buffer, you get a CFFI pointer to this address in memory, you cast it to a double star, which means an array of doubles, and you get P, which is a pointer to the first and all items in the array. So once you have this P, you can do P bracket 0, P bracket 1, etc., index it. And just by doing that, well, you're replacing this, where every single time you write this, you get a very slow process. You get a very slow process that needs to go through layers and layers. If you replace it with P bracket index, then it is jittered into one machine instruction. So it's great for speed. So obviously, what we are going to do in the future, in the near future probably, is actually add a few special cases so that this ND array index becomes as fast as that hack. Okay, so we have planned to improve. Some funding would be welcome. And yes, for now, just try it out on your own code and see if it helps. I mean, well, basically, if you have anything that just uses NumPy and does nothing else, then no, it's not going to be faster on PyPy. It's probably going to be slower. Yes, but if you have some bigger programs that really has parts that are really doing logic in Python as well, then the complete speed of your complete program might get faster by running PyPy. Okay, so now, a completely unrelated topic, software transactional memory. This is a topic that I kind of talked about the past few years. PyPy STM, software transactional memory. It would be a way to get rid of the global interpreter log, and I've been asked about 10 times during this week, what is the status? So here is the answer. Sorry, it does not seem to work. Why does it not seem to work? Well, the basic idea is that you would take, I mean, the idea that I thought might work is that you take your program, a big and complicated program that does tons of things. At one point, it has a loop that does something on every element of some collection, but every single thing it does is mostly independent. So by adding, like you would add a hint or something, and then the process would turn the execution of this mostly independent part to be really run in parallel, and then you have a conflict detection system to figure out which of these things that run in parallel actually gave the correct answer. The correct answer meaning gave the same answer as they would have given if they were not run in parallel. So It's a very nice idea. However, in practice, you get conflicts between the threads, and the conflicts are hard to find. So it means that you're going to spend 2 hours using some tools that I don't even know what they are and they need to be invented, only to find one conflict. And then yes, it's obvious it's this thing that conflicts with that thing, so you fix that, try again, poof, exactly the same bad performance as before, so repeat the process. So you need to repeat the process several times, you have no clue how many times, and then at the end, suddenly you get good performance. Yes, cool, it works. Well, and then the main problem is that it is your program, like the program is not frozen, right? The next time you change anything in your program, poof, you're going to reintroduce some conflict and you're back to square one. And yes. So I think this is enough of an issue to kind of kill the idea. Like you cannot test for the results unless you do some kind of complex test that the execution runs in less than 30 seconds, and then you hope that when you're running the test, your machine is not actually doing anything else, for example. I don't know. So yes, the idea does not work. I mean, it's put on hold for now. And well, the kind of thing we are thinking about is, yes, okay, let's do a standard GIL-free PyPy. It would not be an STM PyPy. It would be basically the same thing as Larry Hastings is doing for CPython. It's a lot of work for us. Well, see Ladding talk later. Okay. Reverse debugger. Reverse debugger is something that I gave a landing talk last year here. So a reverse debugger is an essential tool that everybody needs like once a year or once every 2 years, something like that. Myself, I've needed it twice since the last year. But it's essential. It's a debugger with the ability to go forward and backward. So you run your program and up to a point where you get nonsense, and then like in 95% of the case, you can think 10 minutes and figure out why it's nonsense, and you fix the bug. But in the 5 remaining % of the case, you really have no clue why you are getting this nonsense. And in order to figure this out, use RefDB, basically. RefDB lets you follow the values where they come from in reverse, really. So you put a watch point on a value, for example, and you can run your program backwards. So the program will run until the point where that value changed. It's just very useful. So here is a URL. It's implemented by a different version of PyPy. But it is a version of PyPy with almost no restriction. Like it's a version of PyPy which can run CPython C extension modules, for instance. It's fine. You cannot, of course, go inside the CPython C extension and go backward step by step, but you can go backward over a complete call to a C extension module, for example. That works. Okay, so last, a few random changes that occurred in PyPy the last year. We improved the JIT, mostly by some reduction in warm-up time, which means that, like, if your program really took a lot of time to start, then now it takes a bit less time, probably still a lot, but less. We reduce the memory usage, the memory consumption, mostly the memory consumption that occurred during the startup. So this is just general JIT improvement. We have VMProf nowadays. So VMProf is a high-performance profiler for Python codes. So think about Hotspot, for example, which is the very old, a very old profiler for CPython. So it's something similar, but well, the advantage of this is that it works the same way on Python, CPython, and PyPy. And also, if you use the PyPy version, you can actually follow and see this function here was executed by turning the function, or this loop inside the function was like this loop inside the function was turned into machine code, and you can actually see the machine code. So you can see when things don't go right for some definition of right. CFFI. CFFI is a way to call C from Python, and it works identically on CPython and PyPy. So this alone is the reason why I think CFFI is great, but well, from what I've heard, from what I regularly hear inside conferences, CFFI is actually used by a lot of projects, and that includes a lot of projects that don't have anything to do with PyPy. So the biggest improvement since last year is embedding, which means basically calling Python from C. So if you have a program written in C or whatever, actually C#, C, C++. So if you have this big program, you can write you can write a bit of Python and then compile this. Well, you write a bit of Python, then you execute the CFFI compiler on this, and the output is a standard C library. A standard C library that has the interface that you specify. So it means really you can write any C library with any interface, and you write it purely in Python. And people are actually using it on ARM too, so it works. Cool. Yeah. Okay, so next year, what is going to happen inside PyPy during the next year is probably something like that. We will continue to polish PyPy 3.5, probably go and start 3.6. NumPy in the scientific stack, yes, we will continue working on it. And I mean, by now it's mostly like fixing the major performance issues. And we have actually ideas about how to fix them, so it's just work, just quote. We will play with PyPy without a GIL, and do things like the reverse debugger. We need to port it to PyPy 3.5, which means basically writing an extra module which needs to be adapted from PyPy 2.7 to 3.5. Well, this is the kind of thing that we are looking forward. So thank you. Here is the website.
All right, thank you. Thank you, Armin. Great talk. We have 6 minutes for questions, so okay, just one question there.
Hi. Do you hear me? Because some people have trouble hearing speakers, exactly. I understand. Thanks for the very interesting talk. There was another talk that mentioned a new frame evaluation API from PEP, I don't know, 523 or something, which is used by PyCharm. I saw it in a PyCharm debugging talk. It's also apparently intended for JITting CPython. Can you shed some lights on how this relates to PyPy and whether, I don't know, yeah, you know more about this?
Yes, so yes, it is indeed probably a good thing for CPython, but it's completely unrelated to PyPy. I mean, that's the end of the story, I would say. What we are going to do about it in PyPy is just, well, add support for this indirection for the CPython extension module, and that's it.
So you said that you now support Python really well. Do you support Python specifically? Did you add support for Python, or is it just that the improvements in CPyX make it possible to run the extension modules that Python generates? And if that's the case, did you do special things to make sure, in particular, Python worked well, or did it just fall out of all the work you did on CPyX?
Right. So no, it is all standard CPyX work, but well. We really had the problem of running this big Python module like pandas or something, and had to tweak CPyX until it supports enough of the C API, like enough of the details of the C API to be able to run. Because Python is doing a bit of crazy things like making up some Py frame objects or something like that.
I got a question about the STM. Would it be possible or useful just to have a limited subset of PyPy supporting STM, like a list, a dictionary, and a set implemented that rockets STM, then imported as an extra module? Would it be possible? And does it fit in the philosophy you're following with PyPy?
Yes, I don't know. The answer is I don't know. I mean, yes, maybe it is indeed a good idea to have an independent module in which you send code, but like not generic Python code, but specialized code, and then have it run using STM, maybe.
You said that CPyX, calling across CPyX is slow. What kind of order of magnitude of slow are we talking? Order of magnitude, are we talking nanoseconds, milliseconds?
So what order of magnitude? I'm not sure, maybe 5 times, something like that, I think. And I mean, it's a number that can be improved by adding more special case. I mean, CPython has tons of special case for calling a C implementation of a built-in, for example. And we don't have them just because. So it's a matter of adding that. But yeah, there will always be maybe 2 or 3 times slower order of magnitude. Yes, too bad.
Hello. As you know, we have the end of life of Python 2 coming up fairly soon, in 2020. Is there the end of life for Python 2? Is there plans to keep, I guess, progressing with PyPy 2 after that, or would that be seen as beating a dead horse?
Yeah, that's a very loaded question. I don't exactly know how to answer it. I mean, well, I would say, I imagine that we'll just continue supporting Python 2 forever, basically, just because PyPy itself is written as a pile of Python 2 code. But yes, that's about all I can say.
Well, we are running out of time, folks. Sorry. 2:30. So, sorry, we are running out of time. Well, let's thank Armin again. Great talk, great project. So the next talk in 5 minutes. All right, so welcome to the second talk of the session. We have Henrik and Stefan. They're going to talk about from an old school data management company to data analytics with Python. Let's give them a warm round of applause.
Thank you very much. So I'm Stefan, this is Henrik. Welcome to our talk. And yeah, it's our first time at EuroPython, and we really, really like the conference. And we are also very new to Python, and we would like to share some of our experiences or projects. So we will talk about an implementation project and how we will achieve our visions. One thing is very important. We're talking here about old school data management. So we don't think old school is bad, because if you remember the party yesterday, and if you think about when did the party started, it started when the DJ started to play old school hip hop songs. So we really like old school, but we also would like to share some of our new ideas with you. Some words about us. So we both wanted to join the community, and that's why we are here both. And I'm more a little bit responsible for products. Hendrik is our Python guy, or data analyst. And yeah, he is doing some research in Karlsruhe at the KIT. He's doing his master there. And he has a lot of experience in machine learning, neural nets, cognitive systems. And he's doing a lot of research on event detection in big data streams. We are working for Sobis. Just some small words about our company. So we are a small company from Germany. Our core business are at the moment web applications, collaboration systems, and mobile solutions. And yeah, within the next 20 minutes or 30 minutes, we would like to share our journey, how we discovered Python, why we are using Python, and I will start a little bit with our vision, because we will talk about one of our products at the beginning that exists for 20 years. And with Python, we are able to implement these visions. And then Hendrik will show you how we do this and how we use Python to cluster communication and detect events. And another reason why we are here is we are the new guys, so everything is new and we like it. If you have any feedback for us, it would be a pleasure if you talk to us later, because we can learn a lot. I would like to start, and this is the only, let's say, sales slide, to tell you a little bit about our project. Or our solution. So we are taking care about collaboration and communication in large projects. And the idea is that in this solution, the industry is taking care of correspondence, documents, everything you need in these big projects, and they are sharing this information. This project exists for 20 years now, or this product exists for 20 years now, and it all started with Lotus Notes domain. Does anyone knows this? Yeah, okay. So unfortunately today not a lot of companies are using Lotus Notes anymore, but 20 years ago we started with this product using Lotus Notes. Let's say 8 years ago we switched to Java web applications, and I've learned a lot this week. So we all love Python, but Java is a little bit strange. So, but in 2009 we decided, okay, we have to go to a new technology. Because all of our customers left Lotus Notes. So we had to make this decision. And this was also the time when we decided, okay, we have to implement some agile development methodologies, etc. And 2 years ago, we finally discovered Python, because Python helped us really to implement our visions in our products. And before we start into this vision, what we had at that time, maybe a little bit more about the challenges that we have. In the industry, for example, our customers are building these kind of big plants. And in these projects, they're taking 2 years, 5 years, 10 years, 15 years. We have a lot of communication and a lot of complexity. That means we have a lot of information that we have to take care of, and we have a lot of data that we have to take care of. And this is getting even worse when we have a look at how many people are working in these big projects. So we have different disciplines, we have external persons who are working in this project, engineers, commercial guys, sales guys, project management teams from different suppliers, consultants, etc. So a lot of people are working together. And when we have a look at communication in this project, it's a mess. We have thousands of mails, we have messengers, we have a lot of different systems where this information are stored. And it's really a big challenge for the industry to take care of this information. And this is even getting worse when we're talking about portfolios. So the big players in the industry, they're taking care about thousands of projects at the same time. And we have to find a way to manage this kind of communication and information. And there are a lot of solutions out there. We're trying to solve this problem. And what are we doing? Not just us, but everybody in the industry. We are trying to manage our project communication. So, I mean, in the IT departments, we are using Slack or Jira today, but in this kind of projects, people are still used to manage communication and data in folder. We have a folder structure, we will organize this information. We have tools like correspondence, metadata. We have controlling possibilities with all this kind of manual work. So you can define favorites, tags, reports, filters and full text search, etc. I think you know that from all of your solutions or from different kind of solution. The challenge that we have here, everything is manually. So you have to classify everything manually, you have to organize your data manually in these kind of systems. And this is something, what we call, this is our search content. So if users who are using this kind of systems want to search for specific content or information, it's always like, yeah, I know the topic, I know that there's something in there, and I'm going into these kind of systems, and I want to find that. So we are doing that the same way in our solutions that we provide for the industry. So everything is this kind of search content where you have to look for this information. But we had the vision. So, I mean, we all know Facebook and these cool technologies. So is this kind of manual classification of information still state of the art today? So do we manually have to classify information? Do we manually have to classify correspondence? This was one question that we asked ourselves. And the other question was, we can manage this data, but we always manage this data by, let's say, tags. Who sends it? Who created a document? But we never use the core, the information that is in the document or correspondence itself. And our vision was always for the last years, can't we change the way how these people work to give them a support, to provide some content and information for our users? So our question was, how can we implement the possibility that our application provides content? Can't we present this kind of content to this specific audience? And we always asked us, but we never found an answer to these questions, and we never had the technologies to do this kind of things. So what we did, we talked to our customers like all the other companies too. And when we did that, we got a lot of information back, and we summarized this kind of information. So we developed our vision. The challenge was our vision, we could not implement that with our existing tools like Java and all these things. And just to summarize, our vision is we wanted to implement these cool features like recommendation engines. Yeah? Can't we drill down the information to the information that a user needs at a specific time? Can't we use these kind of project correspondence and communication data to identify domain experts in a project? Yeah? In this big, if you're working in a big company and we have all this information available, can't we profile users? Can't we tell our community in a company, okay, we have this kind of experts, can't we automatically detect this? Can't we identify trends and risks in projects? So if a project manager is opening the program in the morning and the application tells him, yeah, welcome back to your project, something important happened. And please have a look at that. And we also said, okay, can't we implement things like clustering and event detection? So when we have a lot of correspondence, a lot of information, can't we implement an automated process how we bring this information together? And that's what we are going to show you now, because now we will show you how we implemented what we called machine learning as a service that allows us to identify topics and clusters in correspondence. And of course, we did that with Python, and that's why we're here. And Hendrik will show you now how we did that in detail.
Thank you. A warm welcome from me too. I will show you how we solve some of the problems Stefan identified just now. And I will talk about the task of identifying topics, hot topics and events in social stream data. As you can see, communication within projects, emails and correspondence is just a social stream. So what's topics after all? Topics are basically labeled clusters, and clusters are points in space which belong together due to their similarity. So in the picture on the right side, you can identify 3 distinct clusters: the red one, the blue one, the green one and the blue one, and some outliers outside of the cluster. You can depict them as communications or emails or tweets, anything which is a communication basically. And if you manage to put a label on it, you have basically, you have identified the topics basically. So maybe the green cluster is concerned about Order 66, the red one is concerned about project management, and the blue one is concerned about invoices. So what's hot topics after all? Hot topics are basically communications that belong together which grow exceptional in a distinct period of time. It's similar to a trend. A trend evolves over time. You could see the EuroPython as a trend if you monitor the Twitter stream. It begins slightly before the EuroPython and will hold slightly till after the EuroPython, as the message with the hashtag EuroPython will be more in this time period. In contrary, we identify events in streaming data also as exceptional cluster growth, but in a shorter time period, or the building of a new cluster, as there is a communication which is not similar to any other communication which has to be put into another cluster. I won't speak about noise, because this is another hard topic and I could fill more time with it. So what's the information after all which we have available to identify these? Basically, we know our participants, we know our content, and we have the metadata which is manually put into our communication and ordered by our customers. So we can build a communication model. This is a social stream graph. People talk to other people, send messages to each other, and those are maybe tagged with the aforementioned metadata. So we compare messages and tags to each other, but we also identify groups of people belonging together, as they are highly communicative within this group. And outliers, of course, who talk only less with other people, and so on. So what's this graph built, or each communication built of, basically? This is an atomic model. We call it social stream object. Each communication is based on a sender, a content depicted by the edges here in the graph, and a set of 1 or more receivers. Basically, it's a hypergraph, as T1 depicts only one message which is sent to 3 people. If you compare it with big streams like Twitter, you would have a big audience, every Twitter user who is able to see your message, of course. So what do we do? Basically, the hardest topic within it all is cleaning and normalization of the data. Of course, you have much noise in any communication data. This is a machine learning problem, and for example, to remove footer or reply lines from emails or other communication and stop words, we utilize neuronal networks, explicitly a multi-layer perceptron, to remove those lines automatically from email, which is trained on our company data. Then we compare the textual similarity, we compare the structural similarity, who sends a correspondence to whom, and the other similarities are the tags we have the metadata we have within our communication. The similarities en detail are basically relatively simple. They are the term frequency inverse document frequency based cosine similarity between the correspondences or the clusters. And we have also bit vectors which depicts the sender-receiver sets within a cluster and the correspondence. And we normalize tag mutualities between the different correspondences. So the most algorithms suited for streaming data and email and company correspondence could be seen as very slow stream data. Expect one value. So we built a linear combination from the different similarities and generalized them on many similarity measures we can gather from the other things. Lambda here is harder to infer from our system domain, because it seems that the structure who sends whom an email is much more beneficial, for example, for clustering than the actual content for clustering the information. So how do we do this? As we evolved from a Java company, Java is not so good for data science. You need just too much time to build boilerplate code. You can't experiment fast on some new data or algorithm. So I would call it resting in this case. But Python delivers awesome libraries which we utilize for just this course. So we have Jupyter and Pandas for quick experiments on data or trying to implement some machine learning algorithms. We have Spacey, an awesome fast natural language processing library which we utilize to do lemmatization. Does everybody know what lemmatization is? Okay. Basically, we try to get the word stems, the base words from each word to get a normalized representation of the word, which is really fast. We use Flask to expose our services to our other solutions, and we use scikit-learn to implement, for example, multi-layer perceptrons and support vector machines to identify noise in correspondences. And the results of our research is stored in a MongoDB, which is a very good and very fast NoSQL database, but I guess everybody knows this. So what's our workflow? It's slightly different. We came from a normal iterative incremental work, and now we have to do research as some of the solutions still or just don't exist. You have to experiment to get the solutions right. So basically we begin with a Jupyter notebook, do some work, try something out, and from there we go to a design, an implementation, test of course, and a partial deploy of a business functionality, you could say. But due to our inexperience with Python between Jupyter and design between design and implementation, there are often some hiccups, because you have to adapt to the Python rules and can't just build, or it would be really ugly to build Java solutions in Python. So the cycle is a little bit shorter, and you jump over, between implementation and Jupyter Notebook more often than wished for. So how do we interface with our existing solutions? We build Java web applications with their own quite sophisticated security measures, authorization features, authentication, and their own object relational mapper like Hibernate, for example, a quite modified Hibernate which makes things harder, and a multitude of databases which our clients want to be supported. So we have to expose our solution in other ways. And this would be basically, PIRSA stands for our peer system and R for analytics. would be to expose and control API, to revert control back to our other solutions, a resource API, which stands for the findings our algorithms do, and of course a processing and a state management. These are basically the simplest parts of the application, and we call it simple MLAS, Machine Learning as a Service. So what are the challenges we had? The challenges are basically security concerns. We handle highly confidential material in case of plant building or chemical sites. And how do we implement the security, or how do we guarantee that the security between our former systems and the new machine learning systems are held? Then the services therefore must be designed specifically, and we have to adhere to some security standards within the industry. Interfacing was a problem because if we want to analyze data within a former database, then we have to access the database directly, which would break the security rules. So we decided to do a loosely coupled system, for example, on just read, don't write, of course. Then we are relatively inexperienced to the scientific cycle, and so process iterations within iterations may be not the best thing we can do. And we have to gather more experience. And the last concern is an ethical concern. Privacy. This information we build can, of course, be misused to spy on workers, co-workers, how do they work, and so on. So it's a consumer problem. What do we want to expose really from the things we find in the customer's data? So these both processes are not finished, and advice would be welcome. In this case, I want to thank you for listening, and if you have any questions, we would be happy to answer them.
Okay, we have almost 8 minutes for questions, and then we have the break for the coffee break, so great on time, excellent. So any question? Yes.
Can you specifically, thank you very much for a talk and for this tremendous transition from Java to Python. And specifically, I'm interested in what exact tool set from the Python standard library or maybe something else. You don't hear me, right?
Could you repeat the last part? I've understood Python standard library, but...
basically, what was the key things in your decision to switch to Python from Java?
The key thing why we didn't do Java, or the main point, was a search for natural language processing libraries. And we compared them. We have speed constraints. And the fastest natural language processing library out there at the moment would be Spacey. And every millisecond added here or added here would greatly slow down our solution space, of course. And after researching a little bit of Spacey and experimentation, the choosing wasn't hard, because of course we need a multifunctional language on the other part. So data science tools like R, even if it sounds like a pirate language, which is cool, wouldn't come to mind. And Python has great capabilities for interfacing with other technologies, of course. So these were the basic reasons why we choose Python.
Any other question? Yes.
Do you share some of your code open source in some way, or on GitHub or whatever?
Basically, the sharing of the code, the similarity measures the tools, but not exactly the streaming code, unfortunately. Because there are, the reason behind this is not we won't share, we don't want to share, but there are customer-specific meta tags included which would give hints on processes within customers, by customer projects, and this, we can't just do this.
Any other question? Yes.
This transition was hard, or it was not so?
There were some hiccups, of course, and a little bit a bumpy road. The thing is, the first things were not so hard. The experimentation with Jupyter and Python is really a language which you can learn quite easily, but master quite hard. So yeah, we try to get more experiences on this. Right now my solution space seems a little Javanic, I guess, but I have to forget some of the Java things and throw them overboard in my mind to get better systems.
Because I got this transition from Java to any other language is not so favorite. Everybody say,
Yeah, if I can, I won't go back, actually, to Java.
Okay, but I have to admit we are still using Java for the product, so we are not only Python now, so we are using both worlds.
Any other question? We have 3 more minutes for some questions. If not, I can ask a question myself. Very fascinating project and a great success story since for Python, obviously. Yay, Python. Can you give us an idea on the type of scale that you're working at? Like, I don't know, I imagine you have tons of email messages or, you know, chat messages coming in. If you can give a rough idea.
You want to know how many, or?
Yeah, how many messages you go through your system.
It's project specific, but we have, our bigger projects have 200,000 to 500,000 communications, but this is not only the case, there are documents involved also, which are quite large, and we search also the document space, which isn't mentioned here, because for the clustering process, you first don't need to inspect the documents. And this above many projects, but about the amount of projects, Stefan may be better able to answer.
I would say an average project you will have about 6,000 to 10,000 emails a month, so it's not really big data, but you have a lot of additional information that we evaluate, like actions or other messages. And an average customer of ours has about, let's say, 400 to 500 active projects. So that's the average amount of data.
Any other question? We have time for one question. Well, I can also ask the last question myself. So you mentioned privacy issues, and I could imagine some people, especially workers in those companies, could be a little bit nervous. Do you get, I don't know, any feedback or any resistance from anybody, or people are pretty happy, they see the advantages?
Yeah, at the end it's a decision of a customer or company if they're introducing this kind of systems. But we got some feedback, if you remember the slide when I said we talked to our customers. And during these kind of workshops we had a lot of controversial conversations, so you found every opinion. People who like Facebook. They also like this kind of systems, for example. But you also found engineers or project managers who say, no, I don't want to have such a system because I still can think. But this kind of tool, it's just a tool that should support your daily work. So it doesn't force you to do anything different than before. So you find every kind of opinion regarding these tools.
Excellent. Well, thank you very much. Let's thank the speaker again.
Thank you.
So we are breaking for coffee and tea. See you later.
Okay, so for our next session, we have Anna Ravenscroft, and she's going to be helping us overcome cognitive bias. So please give her a warm welcome.
Thank you, everyone, for showing up for the last session of the conference. It's been an awesome conference. I'm Anna Martelli Ravenscroft, and I am a Pythonista. I'm a PSF fellow. I am not a programmer. I use Python to get stuff done. And I studied cognitive science at Stanford. Let me move that over there so I can actually see. So I want to talk today a bit about our brains. Our brains are very clever. They're very good at doing things, but they're also very lazy. They want to reduce the cognitive load. And so if you've seen any of my previous talks, our brains do a lot of little tricks using heuristics and things to reduce how much work they have to do. This can be awesome, and it can cause some problems. So our brains use heuristics, they do automatic pattern matching, and they fill in the blanks, which is great, except when it's a problem. So, for example, lots of fluffy white puppies. They're so cute, and they set up a pattern in your brain so that when you see a brick wall with this fluffy white animal behind, your brain can fill in the blanks and say, oh, I recognize that, that's a fluffy white puppy. Except sometimes it's a cat. So we have these gotchas, these pitfalls. We see patterns where they don't exist. Am I too close to this? There, let's try that. Is that better? Okay. We see patterns where they don't exist. That's where superstitions come from. We have faulty reasoning. This is why we keep having to remind people that correlation does not equal causation. We do stereotyping. We build patterns about groups of people and then apply those patterns to individuals. And sometimes those assumptions based on those patterns are faulty. So speaking of patterns, let's look at some computers and programmers, because we're here at a programming conference. This is Ada Lovelace. She wrote the first computer program. She was working with Charles Babbage on his difference engine, and she wrote a program using his computer to calculate Bernoulli numbers. Moving forward 50 years, how many computers do you see in this room? I've circled them. Human computers were the thing back when these women were working at the observatory, helping to do computations for astronomers. Even in World War II, women were human computers doing all the computations. And then, by the end of World War II, they were building electronic computers. Now, how many programmers do you see in this picture? Women were the first programmers. They took the hardware diagrams, the circuit diagrams, and figured out from there how to actually program the computers. Also, in Bletchley Park, they were doing the same thing. But we still had human computers that were out there working for things like the Jet Propulsion Laboratory. And you'll notice that not all of them were white. This was before the civil rights movement in the US, and they were still hiring women of color because they needed human computers to do the computation, which is great. How many people have seen the movie Hidden Figures? Okay. If you haven't, it's an awesome movie, go see it. This is the protagonist. Katherine Johnson was a human computer at NASA, and John Glenn asked her to redo all of the computations that they had done on the electronic computer because he didn't trust that newfangled gadget. He wanted someone who knew how to do the mathematics before he would trust his life to it. So she has recently been awarded a Congressional Medal of Honor, I believe, for her work. So move forward to the 60s. Mary Ellen Wilkes wrote the operating system for the Link, which was the first microcomputer in the home. In the 70s, Adele Goldberg helped develop Smalltalk. In the 70s, Elizabeth Feindler helped create NIC for the ARPANET. Francis Allen, an IBM fellow and Turing Award winner, laid the groundwork for parallel computing. And of course, the amazing Grace Hopper. I'm sure we've all heard of Grace Hopper. And she's the one who documented the first bug. They actually found a moth in the works. There's now a Grace Hopper celebration of women in computing, which you see thousands of women around you who are all into programming and other forms of technical stuff. These four ladies are Italian women working on the LIGO project that helped to detect gravitational waves with Python. This year we got to hear an awesome talk from Valeria, who told us how we're using Python in cosmology. Marlena, I met at PyCon Italia. She's the founder of ZimboPy, and an awesome lady. And then there's my friend Kay. Kay is a scientist. Kay designs and builds lasers. Why do I bring up Kay? What do you ask someone you meet at a technical conference like PyCon? Where do you work? What's your favorite programming language? What's your favorite library? What do you do with Python? How do you use Python? What do you ask a woman that you meet at a technical conference like PyCon or EuroPython? Are you a programmer? Are you here with your husband? Are you a recruiter? Women don't fit the pattern of programmer that we've built in our brains. Now, my friend Kay is a scientist. If you ask her, are you a programmer? She'd say no. But if you ask her, do you use Python? She uses Python, NumPy, Matplotlib all the time. In fact, she could probably run circles around most of the people in this room with those packages that she uses for her work. So is she a Pythonista? I'd say yes. So, yes, this talk actually is about cognitive biases. So, remember the fluffy white puppies? They're all so cute. I like fluffy white puppies and black puppies, and I like kitties too. I have 2 dogs, 1 cat, and 8 chickens. So, look around your tech conferences, look around your work, look around your meetups. If they look less like this level of diversity and more like this, your brains are going to build a pattern based on that, saying, this is what a programmer looks like. Our brains pattern match automatically. And so if all the programmers you encounter at work and at conferences look like a white male, nothing wrong with white males, I'm married to one. But if all of them look like a white male, anyone who doesn't look like a white male doesn't fit the pattern. It's how our brains work. And so if this is your pattern of what a programmer looks like, when you see a billboard like this with a platform engineer quote, you don't expect to see this as the picture of the engineer. In fact, there was so much pushback on this picture that she created a hashtag, I look like an engineer, because people needed to be reminded that engineers look like a lot of different things. So when you ask, are you a programmer of a woman at a conference? That's cognitive bias at work. And you might be objecting, I'm less biased than most people. I'm too smart to be biased. We only care about performance. We're a meritocracy. There's something called the bias blind spot. Studies have shown that we're less likely to be aware of our own biases than those of others. And intelligence, because we're all really smart people, intelligence is uncorrelated with how high your bias blind spot is, or how aware you are of your own biases. And people with a high bias blind spot take less advice from others and learn less from anti-bias training. There's a lot more cognitive biases out there. Confirmation bias is a big one. It's a tendency for people to want to prove that they're right, that their preconceptions are right. There's in-group bias, where we want to favor people who are members of our own group. We tend to think that others will think like us, will have the same priorities. This is why we run into problems if we don't actually talk to real users when we're creating products, because we think, oh, well, I know what they need. Maybe you do, maybe you don't. But you may simply be projecting your own beliefs onto them. There's selective perception. There's status quo bias. There's a lot of biases. These are just a few. So confirmation bias, here's a test that they give for confirmation bias. The rule is, if the card has a vowel on one side, then it must have an even number on the other side. So, what two cards do you turn over to test the rule? Obviously, you're going to turn over card A, the card with the A on it, to see if there's an even number on the other side. But which other cards are you going to turn over, the 4 or the 7? How many say the 4? Yeah, you guys already know this. How many say the 7? A lot of people who haven't been warned about confirmation bias will say, oh, we have to turn over the 4 because we want to prove the rule is right. Now, as programmers, we know that if we only test to prove that our program is right and works right with the expected input, that we're going to have problems. And so we test for edge cases. We try to break the program. And so we've learned over time, people have taught us, and we've learned the hard way sometimes, to test for breakage, to try and disprove that it's right. Now, about that performance, we only care about performance. This shows up in universities, in orchestras, in a lot of places that you would think of as being very focused on diversity, very liberal, very wanting to be unbiased. They gave a study, they had a study for university hiring committees, where they sent identical resumes out to different committees. Some of them had women's names and some of them had male names. And they found out that resumes with women's names were judged much more critically, even by the women, than the resumes with men's names. And these are people who really want to be unbiased, but this subconsciously was happening to them too. An orchestra was trying to increase the diversity of its membership. They knew that women and people of color were just as talented, but they were having trouble with hiring people. And so they said, we'll do blind auditions. So they put up a screen so that they could not see the performer when they came in and so they could judge only on their skills. This increased the number of people of color who got given offers to join the orchestra, but not so much the women. Why? What do women wear on their feet when they're dressed up? High heels. And musicians, of course, could hear that this person was walking in high heels, and just that was enough of a clue that this was a woman, and they judged their performance more critically. And so they put down a carpet so that they couldn't hear the person walk in, and suddenly women were being offered positions at the same level as the men. How does this happen? Let me sum up. This is what you use to build your model of a programmer. This doesn't fit the model. And so your brain is going to stereotype and say, this person doesn't match the pattern, and look for proof of the pattern that you already have. And so, why doesn't this person match? Why doesn't this person belong here? You're going to try and prove that. You're going to be more critical of errors and weaknesses. You're going to give less credit to strengths and abilities. You will perceive them different. This isn't conscious. This is subconscious. This is at a perceptual level. It's how our brains work. It's not, we're bad people. It's just, we're humans. This is how our brains work. So cognitive bias is getting in the way of our meritocracy. So how do we overcome it? With awareness and conscious effort. I'm making you aware here of some of these cognitive biases, but that you still need to put in the effort to overcome them, to short-circuit them, and to change those mental models that you've built up. Welcome and mentor new Pythonistas. Reach out to marginalized groups. Actively work to bring in marginalized programmers and Pythonistas to conferences and user groups. EuroPython, I think, has done a really good job at this. Get organizations to sponsor people who aren't like you to attend conferences, to speak at conferences. Actively challenge the patterns you've subconsciously built up by offering your brain new and varied input. When you're hiring, avoid gendered ads. There's an app for that. To change I believe these are English only, but there are apps out there that will help you look at how you've phrased your ads to make sure that you're not turning away women and other people from submitting resumes. Use blind resumes where possible. Remove the name, because that's a clue to gender and often to ethnicity. Remove universities and other clues to group membership. Do you really, really care whether this person got their skills from a CS degree, or do you really care about their skills, whether it came from a boot camp or wherever, or self-taught? We all know awesome programmers who were self-taught. Focus more on skills than culture fit. Culture fit tends to fall into the in-group bias. We're going to give more leeway to people who are already part of our own group. Use technology like gap jumpers to do blind auditions to find out what kind of skills this person has before you bring them in to interview them. And when you're interviewing them face to face, short-circuit the cognitive bias by looking first for reasons to hire. You're already subconsciously going to be looking for reasons to weed them out because they don't fit your patterns. So focus on reasons you want to hire this person. Actively look for strengths and abilities from these people. And watch out for imposter syndrome. If your candidate is saying, oh, well, that was a team effort, or I got lucky, that's probably imposter syndrome talking, and they're going to downplay their accomplishments, so take that into account when you're evaluating them. At conferences like EuroPython, PyCon, and your user groups and meetups, look for people who are not like you, people who don't fit the stereotypes. Listen to them. Presume they're smart, just as smart and technical as you are. Believe them when they share their experiences. Look for things you have in common and their strengths and abilities. At a technical conference, presume everyone you meet there is a programmer or does some programming. If you're at a Python conference, everyone here is a Pythonista until you're told otherwise. Stop asking, are you a programmer? Instead, ask, what kind of programming do you do? How do you use Python? Or any other question you would ask someone who you already assume is a programmer. And you may find out that that person is a lot more like you than you expected, and you may learn about niche uses of Python that you didn't know about. I've talked to people who have done all of these different things with Python, including squirrel deterrence. Working together to overcome the stereotypes and other cognitive biases, we all get that much closer to actually achieving a true meritocracy and making the Python community and maybe the world better. Because after all, Python's going to save the world. I don't know how, but it will. And I guess I talked really fast because sometimes this takes longer. So I'm open for questions. I timed this last night in my hotel and it took longer. Questions?
We have time for quite a few questions, so that's good. Any questions? I'll start closer.
Just curious to hear your opinion about the gender pay gap and
About what?
the gender pay gap, that women receive lower salaries than men. We all know that.
Yeah.
In your opinion, and I really appreciate what I just learned here, and I would like to know, how do you look at it and how do you see a potential improvement in that?
So, gender pay gap exists. There's been plenty of studies about it. There's a whole variety of things involved with it, everything from women not negotiating the same as men do when they start a new job, not being willing to ask for raises as much as men do, and sometimes there is subconscious bias in the people who are making decisions about pay raises. So one of the things that you can do is to, if someone is at the same level and doing the same work, go through and use programming to start looking for those gaps and trying to close them. If they're getting the same level of meet exceeds or whatever evaluations, then they should be at the same level as their other people who are working at that same level as far as pay. So. I'm not going there. Thank you. Other questions?
Thank you for the presentation, first of all. And is there any way to rebuild this part in our brains, or how long will it take? For instance, I got lucky in my team. We have like 40% women, and they are core developers, and they're really hardcore. But I still have the stereotype that men are just better, and I know that stereotype. So there's is there a way to undo this learning?
So if you're talking about undoing the mental models we have of what a programmer is, like I said, the best way is to keep challenging it with meeting more people who don't fit the model and getting to know them as people. That helps a lot. Any women here, and men are also welcome, who haven't been to Grace Hopper's Women in Computing, it is an amazing conference, and it can really help, especially women, to overcome that feeling that I don't really belong in tech, because you're surrounded by 3,000 women in tech, and it's great. Really helps to overcome that subconscious bias that we have as well, because we're raised in the same culture. And so we need to overcome it just as much as our men peers do. So that can help a lot. And just seeking out other people, women, people of color, people who aren't like you, and saying, hey, let's talk about Python, or let's talk about programming, or whatever. And it's really helps to change how you view things. One of the things that I ran into, it's not just color or gender, it's also disabilities, things like that. I worked at a history of medicine library when I was younger, and this woman came in and was speaking very, very slowly. And so I was feeling kind of dismissive about her as being, well, okay, so she's not so bright. Turns out, because I equate fluency of speaking with intelligence, or I did at that time. And I found out she was working on her PhD in muscular dystrophy, which she had, which was why she was speaking so very slowly. And the woman was brilliant. I just hadn't personally encountered someone with this and challenged my own mental models of intelligence and verbal fluency. So the more you do that with whatever mental models you have, the better you are off. Now, if anyone here is wondering, why do we want more diversity? I've got a talk called Diversity as a Dependency that you can look up on YouTube. But I'm assuming everyone here has already gotten past that part. But if you do want to review it, you're welcome to look that up. Other questions?
Yes. So in the beginning of your talk, you said a couple of times that these individuals helped compute and those individuals helped create. I kept wondering, why not just say that they computed and created? Is it some kind of third person, perhaps imposter syndrome, if such a thing exists as imposter syndrome in the third person?
Okay, sorry, it's really hard to hear in here. The question is about imposter syndrome? I was having trouble hearing.
Yeah, perhaps if there was a bit of an imposter syndrome in your presentation as well, in the beginning, when you described those women as those who helped create and helped compute, as opposed to created and computed.
Actually, the women that I mentioned who helped create were co-creators. Grace Hopper created certain things and discovered certain things, but the women I mentioned as helped create were actually co-creators. But I could be, I know that I suffer from imposter syndrome, so it's always good to point things out like that. Thank you. Other?
Thank you, that was extremely interesting. You said earlier on in your talk that there is no correlation between intelligence and the propensity to fall victim to blind spots. So why doesn't our definition or our conception of intelligence include this, what seems to be quite an important cognitive ability, not to fall victim to blind spots?
The study that I'm mentioning is actually fairly recent, and so people are still figuring this stuff out. But emotional intelligence and things like that, social intelligence, are different from cognitive intelligence. That's part of it, but it's possible that we all fall into these things just because this is how our brains are made. And so they're orthogonal axes. They're not connected. Whether you have a bias blind spot and you're really, really intelligent, they're completely uncorrelated. That's what they found in the studies.
I'm just wondering why they don't want to redefine intelligence so that it is incorporated. It seems, but that's not maybe...
Yeah, you'd have to look up the study and see how they decided that.
Actually, I'm thinking that any redefinition of intelligence that says Isaac Newton, the greatest genius ever lived, was not intelligent, would fail my definition of what's a word for. He had enormous biases. Nevertheless, he created modern science. How do you weigh those? Anyway, sorry. My question was about anonymizing university references in curriculum. Suppose your company gets 5 to 10 million resumes a year. You can, with great effort, asking your people to spend a lot of time interviewing, you can interview about 200,000, maybe 300,000. As it happens, one of the criteria used to pick those 300,000 out of 6 million is we'd rather hire, other things equal, we'd rather hire somebody graduated from Stanford like you than somebody whose theoretical knowledge comes from a 2 months course or boot camp. Would it be better to go at random? And that's what we would be doing if we deleted, since we can only interview a tiny fraction of the huge number of resumes sent to us.
I agree that it's a hard problem. And I agree that having a degree from a certain university may mean something, but whether that's where they got their skills in programming from may or may not be relevant to how they do their job. So, for example, someone with a degree in music or art or psychology from Stanford who went to a boot camp to learn how to program, are they better or worse than someone who got a CS degree from Iowa University? I don't know, but you would have to look at their actual skills. And so one of the problems that you run into, as you mentioned, you saw the keynote yesterday from the woman who talked about the many paths that we follow to get to programming. Women tend to get into programming through various paths rather than through, okay, I started programming in high school, and then I go to computer science, and then I go get my job. Women tend to take a more circuitous path. And so if you're going for people who got a CS degree at a university, you're going to, just by that criteria, weed out a lot more women than men, simply because of the way that women get into technology. So that's a problem that you'll have to decide how you're going to address. I can't tell you how to address it other than to say be aware of it and think about what kinds of ways you can look to change things a little bit. I don't think it's on. Maybe. Just shout.
Okay. If stereotyping and generalization is across people, it's going to lead us to make
If you haven't gone to the Despicable Machines talk yesterday, you should see the video of it, because that actually is something that they ran into, is problems with machine learning. Because of the corpus that they use, they came up with results that were not unbiased. And so we need to be aware of that as an issue, that our machines, our results from our machine learning is only as good as what we put into it for training data. And a lot of the training data is going to be biased. If it's from news sources, it's going to be biased. If it's from prison records, it's going to be biased. So being aware of that and figuring out how you're going to address it is above my pay level. It is hard for us to recognize some of these things, and so sometimes you need to have someone else look at your data who comes from a different perspective and who may be able to see things that you don't. Having people from different perspectives really does help a lot, because they are not going to be, well, it's like any kind of testing. You want someone testing your results or your programming who wasn't deeply into the problem. Because when you're deep into the problem and busy programming or developing or whatever, you're so deep into it that you've got all of your mental model there of how this should look, what this really means. And so you have all these expectations already built in. You're not going to see the problems. You're not going to see what's going on. You need to have the second pair of eyes out there who hasn't been so deeply involved. And, you know, I know that open source is awesome for programming because, as Eric Raymond said, with enough eyeballs, all bugs are shallow. Maybe we need more eyeballs on these programs that we use and the results that we're getting to make sure that they're not coming up with biased results before we use them to do decision-making about people. Other questions, or are we out of time?
Oh, we still have a bit of time. We can probably
Okay.
do another question.
So, as you can see, I am a woman of color. So what can I do to help other people overcome this cognitive bias?
You can give talks. Seriously, women don't submit talks enough to conferences. We self-select out, and I've heard the excuses, oh, I don't know enough about such and such. I didn't write the book on it, therefore I don't know enough to give a talk on it. Where I've seen issues where someone who, oh, hey, I learned about this thing and used it once, so I can give a talk on it. Women need to be more like that sometimes. We need to be out there giving talks, technical talks, not just my psych talks, showing that we are part of the technical community and valid members. And when someone does come up to us and say, are you a programmer? Yes, are you? And just say yes, and I use Python in this way and that way, and engage them in a conversation and help them realize that, okay, well, maybe that was not a useful question, and help them understand that there are better questions out there that they could be asking. And the more that we get to know each other as people, I think that will help a lot. So, other questions?
Yeah, thanks very much for the great talk. You mentioned removing names and genders from CVs. to prevent selection bias before, like when you see someone's CV. I'm wondering, a lot of the times you actually need to interview someone in person or via Skype or something. Do you have any tips, short of asking all candidates to wear a paper bag on their head and speak through a Darth Vader voice changer, how we can avoid this kind of bias when we're actually seeing them in person and asking them these questions?
Okay, so once you've gotten to the interview point, you've already put them presumably through some level of skills testing. So you know that they've got some level of skills. If you haven't done that, maybe use gap jumpers or something like that to help you build ways to do testing, to make sure that you know that they do have skills before they get as far as an interview. And then, like I mentioned, you can help to short circuit your own bias by looking for the strengths, looking actively for the abilities, for the skills, for the reasons to hire. Because you're automatically already going to be figuring out all the reasons not to, but focus on looking on the reasons to hire this person, on why they are a good candidate. And that will help you to kind of get beyond that hypercriticality that we have when we see someone who doesn't fit the model.
Okay, I think that's all the time we have for questions now. So yeah, thank you, Anna. That was really good.
Thank you.
And we'll have the lightning talk starting in here in 5 minutes or as soon as we're ready, I think.